The slides are in the Discord channel right below the one we're using for chat in the ACM webcast content channel. Go there, go to the end. The second to last thing posted was an FAQ by Bill on how to get the VMs up and running. And the last thing posted that channel was by me. It is, you guessed it, a copy of the slides. So with that said, yeah, why don't we just dig into it? So I'm going to shut video off while I'm presenting, just so it's got a little bit more real estate on the screen. So first off, thank you, everybody. Appreciate everybody turning out today, especially those folks that it's like, 10 o'clock at night, 2 o'clock in the morning. Really appreciate you coming in and sharing your time with us today. Thank you. And, this is Active Countermeasures. We're part of a bunch of sister companies that, allow us to go through and do this. Yay. And I mentioned, if you want to do the labs, you're going to need a copy of the class VM. This is a link to all of the VMs. It should have also been in the email that you sent out. Actually, the email you got would have sent you to a page that a link to all of these things to download. If you're looking at this saying, oh, let me start this now, they're fairly big. They're like 12 gig. So depending upon your internet bandwidth speed, if you've got a 300 meg or higher, yeah, you could probably get through that before we start getting into doing the labs. And I mentioned how you access a VM in VMware is different than how you access a VM in VirtualBox. This isn't threat hunting. This is just kind of, working with VMs 101 type of stuff. But VMware will assign an IP address to that VM. Once you figure out what that IP address is, you can connect to it directly. So I can SSH to that IP address. I can point my browser at it. All of that'll work fine. With VirtualBox, I have to map a port. And I just showed the link to the blog post that I wrote on how to set up port forwarding within VirtualBox. But once you do that, now you just simply point at 127.0.0.1 and whatever port you mapped to the appropriate port on the VM itself, and you'll be in good shape. VMware troubleshooting, I mentioned this. Sometimes the host address, so that last byte, it decides randomly it wants to change it for some reason. It seems to stick to a number between .127 and .130. At least that's the most I've seen this VM bounce around. But if you need to figure out what the IP address is, if you're trying to connect to that .128 address with the browser and it's not working, go in, do this from the console within the VM itself, and that'll tell you what IP address to use instead. Logging in, login name is threat, password is hunting. So if you boot up the VM and it says, hey, you need to type in a password, the password is hunting. When you log into, excuse me, when you log into ACH for the first time, it's going to prompt you for a login name and password. The login name is threat@activecountermeasures.com. Password is hunting2. So all of that is right there if you need it later. Now, I need you to do me a favor, please. And that is, so this shouldn't affect people on VMware, although if you're running VMware, it's okay to go in and kind of check that. But I inadvertently left some safe lists in place. And if you don't know what safe lists are, don't worry about it. I will explain that. But here's what I need you to do. When you first log in, it'll ask you to pick a database. You can pick DNSCat J3 Strobe and you'll be fine. Just hit confirm. That'll load up. And then click this little gear icon up here. Go to safe list. And see how I got a little number here? That's telling me I have 4 safe lists created. We're actually going to go through and create these safe lists as part of doing the class. So just click delete all. Wait, you're deleting all your safe lists. You sure you want to do that, Chris? Yeah, nuke them. And then you should see that button grayed out. So please go in and do that for me. I apologize. When I went through, I always go through and kind of test this stuff to make sure it's all going to work. And I did that. And then I keep a running log of what do I need to back out, and I happen to miss the safe list entries for the VMware version and then the OVA I created off of that. So, excuse me, for the VirtualBox version, I forgot it for that copy, and then the OVA that I created off of that. Some cool stuff to check out. So there is you got to see this. So there is an issue of Prompt Magazine out that is focused on threat hunting. That's it here. Yay. And it's all about threat hunting stuff. It's pretty cool. It is free of charge. If you go to that link, there's a PDF version you can go check out online. Or you can give them your physical address information and they'll actually mail you out a copy. One of the things that's in that issue is a capture the flag contest. So that's something that we sponsored. So with the capture the flag event, you go in, it's a CTF, there's about 25 questions. The first person to get a perfect score gets a threat hunting coin. And if you're not familiar with what the threat hunting coin looks like, hey, I can show you that too. So that's threat hunting coin. It's pretty solid. Yeah, it's pretty solid. It looks pretty cool. Unfortunately, this has been allocated already. So we've been, talking about doing this for a while now. The first person already went through and finished with a perfect score. That was MC. But what we're going to do is every month between now and August, at the end of the month, we're going to go through and say, okay, who is our top scorers? Let's randomly pick 3 of those to give some really good geek prizes to. One of the things I love about giving geek prizes out is that I have to test the geek prizes first and make sure they're cool enough to make it worth sending out to people. So I've actually been playing around with some pretty neat stuff. I've got a hand crank Van de Graaff generator showing up, I think, today to play with. That might end up being one of the prizes. So we try to give some cool geeky stuff out to folks as part of doing this. And here's some classes I'm teaching coming up. And yeah, so if slides are in the channel below the chat channel you're in right now, dude. So look for ACM webcast content. You can grab them there. So this is a refresh of this class. I think we had about 25,000 people go through this class. And we did a complete rewrite for this year. So if you've attended this before, this is going to be kind of different. Some of it will be the same. But what I tried to do is to try and get rid of some of the justification, me talking stuff, and replace that with some more hands-on lab time. Logistics, top of each hour, we shall do a 10-minute break. Halfway through the class, so the 3-hour point, we're going to go through and do a 20-minute break. So this will allow you to, check email, feed the kids, feed the dog, whatever it is you need to do. And everybody's monitoring Discord. So if you have any questions at any time, go ahead and toss them in. Now, some of what I'm going to be working with is command line syntax stuff. Not all of us have spent time working with the command line, so this can seem a little bit challenging. One thing I kind of wanted to point out is anytime you see the little bar character here, that's nested multiple commands. So in other words, what I'm doing is I'm running this command and I'm saying, okay, run this command, but rather than print the results of that out to the screen, send those results to the second command and then have that command process those results and then send that output to this third command and it'll do its magic on that results as well. And then it'll actually present it on the screen. So you may see me doing things like that on occasion. If you're looking at it and you're not sure why, I'm going to try and explain it the best I can. But if you're still looking at it and saying, I'm not quite sure why things were done this way, that's okay. Go through and try removing one of these commands at a time. In other words, go through and say, okay, what happens when I just run the first command? What's that output look like? Why is this helpful, but why isn't it good enough yet? All right, now let me add the second command. Check that out. Let me add the third command and so on. You can also go up to explain shell, take that command, copy, paste it in there, and it'll give you a very verbose description of what that command is doing. That's a really useful tool if you're kind of learning Linux command line stuff. So some of the goals of this class, I want to make sure you walk away from here with a good definition of cyber threat hunting because, oh my God, there are so many people that are wrong and they think they're authoritative. So we'll kind of cut through some of that. I want to talk through what's the process for doing a threat hunt. I want to talk about why we look for persistency first and what's the importance of that. We're going to talk about how we can take that search for persistency and pivot that into a really good endpoint investigation. And then I'm going to make sure that you have some time applying what you've learned to labs to make sure it's really sunk in for you. So are we getting any better at detection? So, every year I change the slide and every year it's really basically the same thing. Here's the deal. Some studies say we're getting better. We used to be, it took 6 months or more, and over half the time it was an outside third party who would figure out you were compromised before you did. And some studies are now saying, hey, we've got that down to like a month. Here's the problem. When you look at the studies that say, hey, we've got that down to like a month, what they're including is ransomware that reveals itself. So, in other words, if the ransomware gets in your network, spends a week infecting things, and then after a week, it says, hey, I'm here, all your drives are encrypted, you're going to have a really shitty day. Folks are saying, oh, so you detected it in a week. Well, no, right? That's like saying, someone came and ripped off my television set. They came back the next morning and told me they were the one who did it. Would I then go out and say, wow, the cops in my town are really awesome? They're solving breaking and entering cases in less than 12 hours. No, of course I would never say that. Cops had nothing to do with it. This person revealed that they did it. Well, this is the same type of thing. The real tell for me is when you look at the money. What did it used to cost us to recover from an incident versus what does it cost today? And that number is actually still going up. So it can't be getting better, right? We're still not quite getting better at this because it's still costing the same amount in dollars and resources and everything else to try and resolve this. So that to me is my biggest reason for saying we need threat hunting. We need something that's going to bridge that gap between, so it lowers the overall average, Sultan's asked. Yes. So, imagine someone gets broken into and it takes them a year, right? It takes them 12 months to go through and figure out that they've been broken into. And then someone else has ransomware that reveals itself after a week. Well, somebody's looking at that saying, oh, so the average is 26 weeks now. We'll add those two up and divide by 2, and there's our average. And, to me, no, those are two different things, right? There is, you actually found it with your processes, and there is the attacker got what they wanted, so they, released it. That's kind of like saying, oh, hey, all of our customer data ended up on Pastebin after 30 days. Yay, we're detecting attacks in 30 days. We're getting much better. No, no, we can't look at it that way. Those are different metrics. So, what does threat hunting do for us? Well, when you look at the tools we have in our toolkit, they tend to fall into one of two buckets. They're either they're protection, they're there to keep the bad people out, or their response. This is what we do once we know the bad people are there. The challenge has been that middle ground area, right? How do we figure out protections have failed and we need to go into response mode? That's that dwell time I keep talking about. That's the one that, based on the data I've gone through and reviewed, I don't think we've really gotten much better than 6 months yet. I think we can drop that number considerably, but it means adopting a lot of new processes. And one of the biggest challenges we have is that these aren't requirements yet. You can say what you want about security attestations like PCI and SOC 2 and all of that. But the reality is most people won't do it if they're not being forced to. And today, the only one with a requirement yet is NIST. NIST is the only one that's had the vision to say, this is something we need to go in and pay attention to. So one of the things I like to do with my hunts is start with a network. Why? Because the network sees all, right? If I have a system, so I've got a I've got a Raspberry Pi running on a desk behind me that's not plugged into the network. It has no wireless running. I'm pretty damn confident no one's going to break into that, not unless they get physical access to my room, right? I don't have to worry about somebody coming in, from the other side of the world and breaking into that system. It has no network connection. It's connecting it to the network that dramatically increases the risk against that system. So it's the stuff connected to the network we're worried about. Well, it only makes logical sense that if attaching it to the network is what raises the risk, we should be doing our evaluation on the network itself. Historically, what we've done is we've gone through our SIEM, right? We said, well, we'll do centralized logging. We'll find it that way. That sounds good. Here's the problem. Number one, are you collecting the right data? Number two, you're not collecting data from everything. And some of those things you're not collecting data from, they can still be compromised. It's not like an attacker breaks into the box and says, oh, well, they're not sending syslog messages someplace, so this system's off the guard, off guard. We're not going to break into this. It doesn't work that way. I have seen, DDoS attacks where a majority of the attack, well, maybe not a majority, a large portion of the systems that were running that attack were thermostats. The little smart thermostat you can buy for your house. It was those things. They're not logging anything. You're not going to find those in your syslog messages. IP-based cameras. I've seen those being used. Again, they're not logging anything centralized. So the fallacy of doing centralized logging is that if that's our full scope of what we're going to review, we're going to miss a big portion of our network. And even for the stuff we're collecting data from, we may not get the data point we need to figure out what's going on. But if we check the network, everything's going to the network. Everything we need to see is right there. The other nice thing about it is to review alert messages sent from a Linux system is very different than the alert systems that come from a Windows box, right? You need somebody who's trained with that. Once you're trained to look for suspicious activity on the network, doesn't matter if it's Linux, it doesn't matter if it's Windows, it doesn't matter if it's an Atari 7800 somebody hacked together and gave it an IP. You're going to check them all exactly the same way. So I like to start with the network because, as I say here, it's the great equalizer. Everything's plugged in. This is the way to go. So, what does a threat hunt look like? I'm talking at a 50,000 foot level here. I'm going to get into the details. So if you have specific questions about a line item, don't worry about it. I got you. We're going to get in and we're going to cover it. But I like to go through the whole process first and then start going into all the details as we go through. So the first thing I like to go in and go looking for is persistency. In other words, system gets compromised. It starts calling out to a command and control server. That call out to a command and control server is going to be persistent. It's going to do it all the time. Right? It's going to do it for an extended period of time because the attacker needs to be able to access that system through that C2 channel. So if we can tag that C2 channel, identify that, we're well on our way to figuring out what systems have been compromised. Once I find a system that seems to persistently be talking to somebody out on the internet, the next thing I go in and look for is there a business need behind that? In other words, if this is my Mac checking an ntp.org system to see what time it is, yeah, that's a persistent connection, but I don't care. There's a business need for that. If it's my Windows system calling out to check for patches on a regular basis, again, there's a business need for that. I'm not going to worry about that. So when I find persistency that I can explain away with a business need, I'm going to create what's referred to as a safe list entry. A safe list entry says, I found this in my hunt. I evaluated it, and I deemed it to be business worthy. In other words, my Windows systems need to check for patches. That is an expected behavior. I am going to create a safe list entry to ensure that that specific activity doesn't show up in tomorrow's hunt or the day after that or the day after that or the day after that. What's nice about that is once you've done your hunt 3 or 4 times, the only things that are going to show up in your hunt is new stuff. In other words, my box has never been beaconing out to Quanzhou, China, and all of a sudden it is, boom, that sticks out like a sore thumb in a threat hunt. So your first couple of hunts, you're going to find a lot of stuff that you look at and you say, well, actually, this is okay. But once you've done like 3 or 4, you've safe listed all of that. Let's just call it noise for the sake of argument. All that stuff that there's a business need behind and you're not worried about. Everything else that shows up, yeah, that's stuff you want to act on. If I can't figure out a business need, the next thing I do is I go in and I analyze the protocol. So we're going to dig in and we're going to say, okay, is there something weird about this? One of the common things you'll see with like HTTP or HTTPS sessions is that you'll have a system that identifies itself one way consistently with everybody it talks to on the internet. Like, hey, I'm a Windows 10 system. I'm a Windows 11 system. And everybody it talks to on the internet, it's using a user agent string that says, I'm a Windows 10 system. But there's one IP address it's talking to on the internet and it says, oh, hi, I'm Windows 7. Something's weird there. That's an odd use in the protocol, right? They're not breaking the protocol rules, but they're certainly bending them. And that makes it something more interesting to go in and take a look at. So I'll go in and I'll analyze that protocol to say, is there anything here that makes me additionally suspect about that system? If any of these, if I still can't identify a business need, if the protocol looks weird, my next step is an investigation of that host itself. And that's what may be when I jump into my SIM. That may be when I go in and say, okay, having the context of knowing my system is talking to a host in Guangzhou, China, where I don't have a partner, a field office, a vendor, or anything like that. And it's doing it every 30 seconds all day long. With that context, I will go check my system logs to see what do I need to worry about here. That makes it a whole lot easier because I'm not relying on simple pattern matching based on the behavior of old attacks to try and figure out when I've been broken into. I have context of what's actually taking place in my network at the time. Once I've gone through all of this, now I either say, yep, nope, this is good, add it to my safe list, or nope, it is bad, we need to go into incident response mode. But start on the network. So here's a good example. So I've got this internal system, 192.168.99.51. It's talking to this IP address out in DigitalOcean. Maybe I got resources out there, maybe I don't. One of the things that kind of grabs my attention is these two sections here is telling me that nobody queried a fully qualified domain name via DNS that resulted or that returned this IP address as an answer. In other words, this was pre-programmed in, or that it was a direct IP address connection or something along those lines. That's odd, right? That's not enough to say, whoa, we got to freak out. But you look at that and you're like, well, but how often does that happen? Well, it's not that often, right? So that makes me a little bit more suspicious about this connection. Now we're looking at a 24-hour period of time here. It's just shy of that, maybe about 23 hours. And 9,000 connections took place over that period of time. Okay, that's a lot. Now, if I plot out those connections over time, what I see is something like this. So my graph here on the bottom, my x-axis is time. Each bar represents a 1-hour period of time. My y-axis is quantity. How many times did this system initiate a connection to that system in this 1-hour period of time? And you can see it's about 120 times. So that's about 30 seconds. Now, from a behavior perspective, look at this. It's doing it every hour all day long. Well, that's weird, right? That's weird. Why does it need to talk to this system so consistently? What is the story behind that? Right? Everything tells a story. What's my story here? Is there a business need story that might explain this? And if not, then we're probably going to have a bad day. This chart here is going through and breaking out. I said it's calling out about every 30 seconds. Well, is it exactly 30 seconds or not? That's what this chart helps me figure out. So this chart breaks out how many seconds went by between connections. That's my x-axis. And my y-axis is how many times was that time delta used between connections. So in other words, there was, 28 times? Yeah, 28 times, 28 seconds, just under 1,000 times, there was a 28-second pause before this thing connected up again. And about little more than 1,000 times, a 29-second gap took place before this connection took place. 400, let's call that 450, just to round it to a round number. 450 times, there was a 27-second gap. Let's call that 25 times. There was a 31-second gap. Notice this is not going off on an exact interval. It's varying the timing a little bit. We'll get into this more later. This is what's referred to as jitter. And attackers do this to try and circumvent folks like us who are trying to find command and control channels on the network. Now, obviously, here it didn't work. But for a lot of tools, this will work out very well for them. I mentioned, I listed this as Cobalt Strike. Yeah, this is actually a well-known C2 tool called Cobalt Strike. Everybody uses it. Red teamers, the bad guys, nation states, everybody seems to rely on Cobalt Strike. And one of the nice things about Cobalt Strike is it has a very identifiable signature if you know what to look for. When it's jittering the connection, it's always going to create this little bell curve shape here. So anytime I see a connection like this, and then I come up to this graph here and I look at how the time deltas are mapped out and I've got this little bell curve, I know, yeah, this is somebody running Cobalt Strike. So this is either my internal red team testing the blue team, or something's whacked and we're going to have a bad day. But now that I know this, right? Now that I know I've got a persistent connection here, if I need to dig into this further, right? Notice I've got the circle around the little Beaker icon there. We have an open source project we maintain called Beaker. And what Beaker does is it leverages sysmon to collect ID3 information. ID3 is an application that was launched on the local system that communicated with the network. So it might have held open a port. It might have reached out to a remote IP address. It's doing something on the network. It's not just running a local application. And we record that because if you think about it, that's kind of the bare minimum I need visibility on for my hosts to actually be able to figure out what's going on. So once I see this, I can click the little Beaker icon, and then that will automatically load up that same date time range, and it'll send a query into Beaker that says, hey, when this source IP address was talking to that destination IP address. Oh, well, actually, yeah, okay. I used two different screens here, but it'll send a query into Beaker that says, hey, when this source IP address was talking to that destination IP address over this time frame, what was the application that was responsible for making that connection? And in this case here, I can say, oh, okay, that was Runtime Broker. Well, Runtime Broker is a Microsoft tool that enforces permissions on apps you download from the Microsoft store. Wait a minute. Well, then why the hell is Runtime Broker talking to DigitalOcean? Oh, because Microsoft doesn't trust Azure and they put all their servers in DigitalOcean now, right? That's what this says. That's the story saying. Runtime Broker is calling out to DigitalOcean to check for permissions because that's where Microsoft locates their servers now. No, that's not going to happen, right? Microsoft is not going to do that. So the fact that this app that is supposed to be a Microsoft app is calling out to DigitalOcean? No, something's wrong. This is clearly not the Runtime Broker we think it is. Now, we would probably not, we would probably not write a SIM signature saying generate an alert anytime somebody runs Runtime Broker, right? Because we're going to see tons of false positives. We're going to be sorting through alerts that mean nothing constantly. It's going to be a complete waste of time. But here we have context, right? Here we know, well, that was running on this IP address and it was causing a connection to that IP address and it was doing it on a regular basis. Well, with that context, we know this we need to worry about. This we need to dig into deeper on that system. Are the beakers always visible? I don't see it. No, they're not. If you install AC Hunter and you install Beaker at the same time, it'll create this icon and set everything up for you. If you don't install Beaker at the same time, you need to go in and tweak AC Hunter to tell it that where Beaker's located. Now, one big thing for me is that when you're doing a threat hunt, you never, ever, ever cross the passive active line. What do I mean by that? I mean that you need to look at this from the perspective of your attacker and identify, is the thing I'm about to try something the attacker could detect? In other words, this is collecting logs off of that endpoint. I'm checking the logs on a server that is not the endpoint itself. The attacker is going to have no way of knowing whether I'm looking at these logs or not, right? Well, what if I log into the system and I start running the task list command? Well, the attacker could potentially see that if they own that box, right? That's crossing the active line. That's going into something that the attacker could detect. Do not do that during a threat hunt. That should be part of incident response only. Why? Because it's really easy to make stupid mistakes in the moment when you're the only one making those decisions. One of the nice things about an incident response team is the last keyword there, team. You have a bunch of smart people together that may think of things that others don't. When you're threat hunting, that tends to be more of a solo function. You're more likely to make a bad choice about something. And I'll give you the most common one I say. The most common one I see is somebody's threat hunting. They find a system like this. and they say, oh, yeah, no, it looks like this system's compromised. Let's isolate 99.52. Let's put it on its own unique subnet. We'll use the switch to go through and isolate it off. Is that detectable by the attacker? Yes, it is, because they're going to lose access to it. You've isolated that box. That means the attacker might figure out you're onto them. Now, if this is the only box the attacker has access to, no harm, no foul. Everything's going to be fine. But if the attacker owns another dozen boxes that you haven't found yet, I can tell you what's going to happen because I've seen it. The attacker is going to lose access to this box. They're going to say, oh, crap, are they on to me? The next time one of those other 12 boxes calls home and says, hey, because they're not doing it as often as this one. This one might be calling home every 30 seconds. The other 12, they're doing it every 6 to 8 hours. They're really trying to fly under the radar. So what they do now is the next time one of those boxes calls home after 6 to 8 hours, they say, and says, hey, do you have anything for me to do? They tell it, yeah, you're now the primary conduit into the environment. Then from that box, they probe and see you've isolated this one, and they figure out, oh, crap, they're onto us. Let's go scorched earth. Let's start deleting everything and anything we can get our hands on. Maybe we start running internal DDoSes to slow them down, to try and make sure we clean up as much as possible before they can actually do anything to us. In other words, they start beating the crap out of your network and deleting things because you isolated this one box. Now, had you gone in instant response mode, hopefully someone in the room would have said, whoa, wait, before we isolate the system, let's do a full scope check. Let's go look at the firewall log to see if anybody else is talking to this same destination IP address. And if you did that, you would have seen, oh, yeah, there's 12 other systems talking to that same IP address. It's not as often, but they're still doing it. Okay, great. Now let's not just isolate this one box. Let's isolate all of them at the same time. That's going to be a much better process forward. So that's what I mean by don't cross the passive active line. Threat hunting is just simply, go in, discover what you can without tipping your hand to the attackers if they happen to be on your network at the time. So let's talk about some detection techniques. So where to start? Well, we need network traffic, right? We're going to analyze the network traffic. We got to kind of see the network traffic to be able to go through and analyze that. Historically, this has been through PCAPs. People go through and make full packet captures off of the network. That works. Here's the problem. It takes up a lot of space. It takes up a ton of storage. You're talking about all the data you're moving on the network. You're going to try and store that on one disk or in one set of disks. You're going to run out of space eventually, right? Depending upon what your network bandwidth and how much network space or how much disk space you have. Those two factors are going to determine how long can you store this data for. And what most sites tend to run into is they can't store it for that long. Today, a better way to do it is to go through and use Zeke. Zeke is not an intrusion detection system. I see it mislabeled that way all the time. Zeke is a network recorder. It goes in and it basically identifies the highlights of the sessions that went by. So, for example, if somebody talks to a web server, it's not going to store every single packet and everything in those packets, including the things you probably don't care about, like the CRC and the IP IDs and stuff like that. It's going to go in and it's just going to say, create like 2 lines that say, hey, this user connected to that web server, and here's some of the application data that was associated with that. It takes up a lot less storage that way. My experience has been it takes up about 1/20th the storage. So look at it this way. Let's say you have disk space and you're storing PCAPs, and you have enough disk space to store 5 days worth of PCAPs. Think about this from an incident perspective, right? Something goes wrong on your network. What you're basically saying is, I can only go back 4 or 5 days. And anything that happened beyond that, I have no idea. I have no visibility at all. So in the midst of an incident, you're only going to have 4 or 5 days worth of visibility, and that's it. But if you were using Zeke instead, 20-to-1 difference, you could store 100 days worth of information. That's going to give you much better visibility on what's going on. So I like to go through and use Zeke. When I go in and I go looking for things that are interesting, like persistent connections, I try to work with as much data as I possibly can get away with. 12 hours minimum, 24 hours is ideal. Now, if you work for a government agency that is normally described with 3 letters, you might want to keep 7 days instead of, work with 7-day blocks, not just a 1-day block. That's entirely possible. But for most of us, 24 hours works out fine. One of the most stealthy nation state attacks we've seen has been Sunburst, right? So that was a supply chain attack. So they got SolarWinds to digitally sign their malware and push it out to their customers. Gee, that was nice of them. And I don't think they charged them anything for that service. But that compromised every SolarWinds server that updated to that new code. The C2 channel that got installed on those SolarWinds servers called out every 15 minutes, and it would jitter by 90 seconds. So that delta time was anywhere between 13 and a half minutes and 16 and a half minutes. That's fairly patient for a command and control channel. So what if most threat hunting tools store 20 minutes of data and analyze data in 20-minute chunks. All right, if I'm using one of those tools and I'm looking at 20 minutes and I'm looking at Sunburst or a Sunburst equivalent, how many data points do I have to work with? Probably one, right? Maybe two. Is that enough to figure out this consistency, this data persistency? No. Right? One, maybe two connections? No, that doesn't tell me if it's persistent or not. That just tells me a connection took place. So a 20-minute window, like most tools use, is totally insufficient for finding high-end C2. Now, what if you use 24 hours, like I'm suggesting here? Well, let's see. It's about every 15 minutes. That's 4 times an hour, 4 times 24. That's going to get me just less than 100 data points. With 100 data points, can I figure out it's going off about 4 times an hour, 24 hours a day? Yeah. Can I figure out that's persistent? Hell yeah, if I'm looking at it right. So that's why I'm saying, 24 hours is your best bet. That works out just fine for most organizations. So your typical deployment. So what you want to be able to monitor is all the traffic going in and out of the internet. So what I may do is take my switch and create a span port that says, hey, anything going in and out of the internal interface of the firewall, send a copy of that to the span port, which now has Zeke running. And Zeke's collecting all the packets that come in from that span port. And there's a second interface on that box unless I need to connect to it directly. So that allows me to see everything going out to the internet. Now, what about users working from home? This doesn't work. I'm going to have to figure out something agent-based to go through and work with them. But anytime I have a collection of systems on a network, monitor the choke point on that network, and this is going to allow me to some pretty decent visibility. Does targeting C2 have its blind spots? Well, of course. It's going to be any malware that doesn't use a command and control channel. Now, with that said, those are incredibly rare. The first major attack we saw on the internet was the Morris worm. Morris Jr., not Morris Sr. Morris Sr. was the one who came up with DES encryption. Morris Jr. was the one that was trying to keep up with his dad and thought this would be a good way to study systems. And oops, it got out and it totally shut down the internet. I hate it when that happens by accident. But the Morris worm had no C2 component to it, not Petya. Right. So NotPetya was the Russians going after Ukraine yet again and deciding they wanted to try and shut down businesses within Ukraine. So they went into a system that people doing business in Ukraine would leverage for paying their taxes. And they attacked that system and did a supply chain attack so that anybody pulling down the information they needed as part of paying their taxes was also getting the malware. The thought process being, well, we'll just, go after everybody doing business in Ukraine. Well, here was the problem. The problem was a lot of companies don't do business just in Ukraine. They do business in Russia as well, and Russian systems were starting to get hit. Global shipping ground to a halt because of this. This had such a much larger impact than I think the people who did it intended. That we've kind of realized that we're basically like throwing a nuke over our shoulder with this. Without having a C2 channel, without having some way to critique it or curtail it or direct it or to do something with it. So an overwhelming majority of the malware you're going to run across is going to have a C2 component. The other thing is without a C2 component, the only thing it's good for is blowing shit up, right? I want to destroy that network. That's the only thing you can do with it. You can't go in and say, hey, I'm going to ransom that network, right? Because you need a way to be able to interact with it and be able to unlock it. If you don't, if you let them unlock it, they may be able to unlock it without your input, and that would be a bad thing. So again, most malware is going to have a C2 component, but we do occasionally run across ones that don't. And yeah, the process I'm talking about may potentially miss that. Nothing is 100% perfect. But just because something isn't 100% perfect doesn't mean we can't leverage the benefits that it does afford us. So start by checking persistency. So, like I said, this is, I've got an internal system that's in constant communication with a host out on the internet. When we look at what shape can that take? In other words, what could those persistent connections look like? You kind of come up with two options: a long connection or a beacon. What's a long connection? A long connection is simply the attacker gets malware on that system. So typically that occurs because the user clicked something they shouldn't have. And once they do, that gets that system infected. And then that system calls out to a command and control server, and the command and control server is going to feed it its marching orders. One of the ways that that connection can be maintained is through a long connection, meaning it just connects out to the C2 server, holds that connection open indefinitely. If the connection gets shut off for some reason, it just immediately reestablishes it. These are kind of hard to go through and find because not many network devices really give us good data here, right? Like one of the first things I thought of when I was thinking about where can I go looking for long connections is, I can just go look at the state table on my firewall. My state table on my firewall is going to track this, right? No. An overwhelming majority of the state-based firewalls that are out there today, both commercial and open source, don't track the longevity of the connection. The timer that they keep track of is when's the last time I saw a packet associated with the session. It doesn't identify when did the session actually get started. That's one of the nice things about Zeke. Zeke will record that. Now, to have Zeke do it right, there's a couple of tweaks you need to make, and we'll talk about those. But, cumulative communication time, this is one of the things that we want to go in and look for. AC Hunter, which we're going to go in and work with, has a screen for analyzing long connections. You have two views here. In view 2, I'm looking at the length of all my individual unique connections, right? So if somebody connects out to a host, holds that connection open for 20 hours, that's where I would go in and kind of take a look at that. The default view, view 1, is the total duration of the communications between these two endpoints. And that's important because there's some malware like Metasploit. What Metasploit does is Metasploit calls out to its command and control server, holds the connection open for 30 minutes, kills it, immediately reestablishes the session, and again, does that for 30 minutes, kills it, reestablishes, and does that all day long. And the reason they do that is kind of ingenious. Because if I'm looking for long connections, typically I'm looking for connections that are like 20,000 seconds or longer. That's about 5.5 hours. Right. That's enough to say, hey, you've been running the whole time during a business day. That's worth going in and paying attention to. Well, since Metasploit is only holding a connection open for 30 minutes maximum, if I'm looking for 5.5 hours, 30 minutes is way below 5.5 hours. That's going to stay off my radar. I'll never pay attention to that. If I'm looking for beacons, a lot of folks go looking for beacons based upon, am I seeing thousands of connections taking place a day? We looked at one earlier and it was, there was 9,000 connections that took place over 24 hours. So folks go in and look for stuff like that. Well, Metasploit is connecting up every 30 minutes or less than 50 times in a day. So if I'm looking for 1,000 connections or more to say it's worth analyzing as a potential beacon and it's doing less than 50, it's going to stay off the radar. I'm not going to pay attention to that. So what we do for a default is we look at cumulative time. How out of the last 24 hours, how much of that 24 hours have these two systems been communicating with each other for? And in the case of Metasploit, you'll see, yeah, it's been 24 hours out of the last 24 hours. Oh, good. Now I know that's something I need to go in and pay attention to. There's a column here labeled state. Anytime I analyze a PCAP file, like we're going to be doing in our labs, it's always going to list the connection as closed because it assumes that connection's done once it gets to reading the end of the PCAP, right? There's no more data to work with here. But if you're running live, Zeke's got a little bit of a problem with it. are a little bit of a problem. What Zeke does by default is Zeke doesn't record things until the connection closes. Now, a majority of the time, that's not a problem. But when we're talking about long connections, that can be a huge problem. So imagine I break into one of your systems. I set up a long connection back to my C2 server, and I go in and I start playing around in your network. Zeke will not generate a log entry off of that connection while that's occurring. So if you check your Zeke logs every day, you will see nothing that will give you any hint whatsoever that I'm currently working on one of your systems. Now, let's say after 3 months, I'm done and I decide I've stolen all their intellectual property. I've gotten everything I needed. There's no reason to stay on this network anymore. I'm going to kill and clean up after myself and back out of this network. Well, as soon as I kill that C2 session, now Zeke writes a log entry for you. And it'll create a log entry that says, hey, this system out on the internet, your system was persistently communicating with that for the last 90 days. And you're like, whoa, wait. I look at my logs every day. What happened to day 1? Day 2, day 3, all the way up to 89. Why am I seeing nothing until I got to day 90? And it's because Zeke doesn't write the log until that connection actually completes. So one of the things we do with AC Hunter, and we do this with Rita as well, is every hour we go through and we look at what is Zeke written in the logs and what's still in its state table. What connections are still active so it hasn't bothered to write those out yet. And we'll go through and we'll do a diff between the two. Basically, we go in and we say, what is in memory and in that state table that hasn't yet been written out to a log? Whatever the difference is, whatever has been written to a log yet, we're going to show it on this log connection screen and that we'll list the state as being open. So in that case, let's take that exact same scenario I described. After a day, you would see your internal system was talking to my C2 server for 24 hours. An hour later, you'd see it's been talking to it for 25 hours. An hour later, 26 hours. An hour later, guess. What do you think? 27 hours, right? Exactly. So you don't get the 90-minute surprise. Every time you go in and look, you're going to see the hours getting added in until there's enough of them for you to say, oh, for 4 days now, it's been talking to the system in Guangzhou, China. And I don't have a business partner here. Maybe this is something I should go in and take a look at. But at least you're responding in 4 days, not after 90 days when I'm already done and I've left your network anyway. So, what is a beacon? So, a beacon is a repetitive set of communication sessions, right? So, I've got an internal system, it's calling out to somebody out on an internet, and it's doing it in some sort of repetitive basis. It might be once per second. We looked at an example that was every 30 seconds, and it does that all day long. That's what's typically referred to as a beacon. It's repetitive connection establishment taking place between an internal system and an external target. And that external target could be an IP address, it could be a fully qualified domain name. I'll get into the differences between these two as we go through. But that's a beacon in a nutshell. So, how does, let's call it classic command and control, because there's lots of variations off of this, and we'll talk about some of them as we go through. But how does classic command and control work? So, my attacker over here sends an email to this user and gets them to click something they shouldn't have, right? That gets malware on this box. So now this box is infected. Well, there's a firewall here, and this system has a private IP address. So it's not trivial for the attacker to try and get a direct connection to that system, right? They probably can't, unless they can do some sort of source route magic that, like I've only seen Bill Stearns do. It isn't going to happen. So they need another way to maintain communication with that system. Well, they do it by setting up a proxy. They set up a third party. And the proxy just says, hey, you talk to me and you talk to me, and I'll just broker the communications between the two of you. That's what a command and control server is. So the attacker, before launching this attack, sets up a command and control server and says, hey, you're probably going to have people connecting to port 80, or whatever it's going to program its malware to connect up to. When it does, assign it a work queue. So now this system gets compromised, right? That malware gets launched. It calls out to that command and control server and it says, hi, I'm here, I'm compromised. Do you have anything for me to do? And typically the first couple of responses are, nope, there's nothing in the work queue for you. Go back to sleep. And now this system will pause by whatever dwell time it's been pre-programmed to pause for. And at the end of that dwell time, it will connect back up again. Hi, I'm still here. You got anything for me to do? No, go back to sleep. Wait 5 minutes. Hi, I'm here, or 10 minutes rather. Hi, I'm here. Do you have anything for me to do? No, go back to sleep. And it just does that every 10 minutes all day long. That's our persistent connection that we're in there hunting for. Now, let's say the attacker wants to do something. Let's say the attacker wants visibility on all processes that are running on that system. It can log into the command and control server and says, hey, the next time this system checks in, tell it to run the task list command. Great, no problem. So now this system checks in and says, hey, do you have anything for me to do? The C2 server says, yeah, actually, I need you to run the task list command. No problem. Now the malicious code runs the task list command, takes the output from that command, shovels it back out that same C2 session, and adds that into its work queue. Now our attacker can go in and view that information. Typically, what's going on the server is somewhat invisible to the attacker. The attacker is going to connect up and say, run the task list command as part of their session. And they'll wait some period of time that is, 10 minutes or less. And then all of a sudden, they'll see all the data pop up on their screen. That's typically how the interaction goes from the attacker's perspective. But notice no inbound connection is required. I've got the compromise system calling out for me. This is your classic command and control session. Now, one of the things attackers are starting to do that's pretty damn savvy, and it's hard to catch, is rather than connecting to a system, right? And you may notice this now. Hey, it's connecting to Guangzhou, China, and I don't have a business partner there. You might notice that. What they're doing now is they're taking their command and control server and they're putting it behind legitimate content delivery networks. I've personally seen this done with Akamai and Amazon, but I would be hard pressed to think it's only those two. It's probably happening with other CDN providers today. I think I'm probably noticing it on those two because they're two of the biggest. So now what happens is this system is pre-programmed to say, hey, call out to foo.evil.com and check in to tell it you're in a compromised state. So it does that. Well, this is a content delivery network. So which means when it resolves this IP address, it might resolve to this IP first. So it does its connections through that. But then after 5-10 minutes, if this system gets busy, it might change and start doing it through that, or it might load balance across these two. So some of it goes here, some of it goes here. Notice the problem. I'm not beaconing out to a single IP address anymore. I'm beaconing out to multiple. So that clean signal we were looking at going out to a single address is being spread out across multiple addresses. I need a way to be able to collapse those back down together and look at it as just one beacon signal only. So that's problem number one. Problem number two is this is a content delivery network. Legitimate companies use it too. So I'm going to see, my Skype traffic going out through here. I'm going to see my Windows.com traffic going through here, my Microsoft.com traffic going through here. So sometimes the connection going out to this system is evil and sometimes it's good. And I need to be able to distinguish between those two if I'm going to do proper beacon detection. That's what makes this a whole lot harder. So when we get into like CDN networks, you've got to be doing this at an application level. You can't do this based on just the destination IP address anymore type of thing. So most beacon detection is done based on timing, like we're talking about every 30 seconds, every 10 minutes, every 15 minutes, whatever the case may be. It can be done based on session size as well. And I'll talk about that in a minute, but most of it's based around timing. The most common algorithm that most tools use is k-means clustering. So you can look this up, k-mean space clustering. There's a wiki on it. Basically, k-means is math. It's math designed to analyze large data sets to look for repetitive patterns. So imagine, I had 1 million connections go out to the internet yesterday from all the different systems that are on my network. There's 1 million connections that went out to the internet. But buried in there is one system that every 30 seconds is connecting out to the same IP address every single time. Well, that's a repetitive pattern, right? K-means can spot that and identify it as something you should pay attention to. So that's why a lot of tools use k-mean clustering. Here is the Achilles heel of k-means clustering, jitter. As soon as you start jittering it, like that connection we looked at earlier, where it wasn't exactly 30 seconds, sometimes it was short as 27 seconds. We had a couple of them that were 31 seconds. As soon as you start jittering it, K-means looks at that and says, well, that's not an exact repetitive pattern anymore. So I don't need to pay attention to that. So I will ignore that and not tell the operator they need to pay attention to it. Well, a tool that relies on K-means to find attackers, anything that jitters, they can't detect it. So they need to fall back on signature matching, which means the only thing they can detect is stuff that's already known. Anything new, they're going to automatically miss. Well, that kind of sucks, right? Yeah, it does. That's why we stopped using classic AV, right? Remember, classic AV used to be based on signatures. And that worked great in the 90s, when we were connecting to things with modems. It doesn't work in a modern internet society. It's too slow to say, I'm going to wait until one person gets infected and then try and warn everybody else. No, it's usually too late. Usually by the time you detect it, multiple people have been infected and everything's falling apart. This doesn't work. That's why we've gone to application whitelisting. We're checking digital certificate, digitally signed software is the only thing allowed to run. And, we've had to go on to other means because it doesn't work. This is the same type of problem. Exact same type of problem. So if it's jittered, which, oh, by the way, every actual malicious connection I've seen for at least 2, probably 3 years now, have every single one of them have been jittered, K-means isn't going to work. Anything going through a CDN network, K-means isn't going to work. So one of the first questions, anytime you're looking at like a network threat hunting tool, question number one should be, so what are you using to detect beacons? And if they say K-means clustering, thanks for playing. Thanks for playing. When you get your code updated, we will talk more later type of thing. So I've talked about this, mapping this out over a period of time. This to me is the best human visualization to figure out I've got a persistent connection. If I can go through and kind of look at it this way, what's nice about this is that this will normalize out a lot of the jitter. For example, let's say I'm going to go for something extreme. I'm going to beacon once per minute plus or minus 50%. So that means my delta time might be as short as 30, it might be as long as 90. That's a pretty wide swing, right? Well, think about law of averages. I'm going to pick 30 seconds about as often as I do 90, right? Average those out. What do you get? 60. Oh, yeah, that's in the middle. So, in other words, and remember the bell curve that we saw when we were looking at Cobalt Strike? It's grabbing the middle more often than the ends, and it's grabbing the ends about as often as each other type of thing. So, by analyzing things in buckets of an hour, you're actually normalizing out a lot of that jitter. So this is one of the better ways to go in and do our detection. So if I do have a persistent connection that's not jittering, I was talking about that kind of top right-hand screen up there, right? I'd see something like this where, here's everything going off at a 1 second interval. But if I've got jitter, I'm going to see something like this. And as we said, if you looked at this and thought Cobalt Strike before you even read the text, good. That's what I'm hoping you're going to pick up on. I want you to be able to do that live in the field type of thing. Now, look at this one. This is my favorite C2 channel. And I know that's a weird thing to say, especially as a solid blue teamer, for me to have a favorite C2 channel. But what I like about this is the most effort I've ever seen an attacker put into trying to randomize their jitter timing as much as possible. This is the best I've seen out there. But looking at this in 1 hour chunks over 24-hour period of time, it still normalizes out a lot of this jitter. It's still trivial to go through and pick this out as a persistent connection. So even with the best of the best, this methodology I'm talking about, you're still going to be able to find stuff like that. All right. And with that said, let's take a break. So it is now the top of the hour. We're going to take a 10-minute break, and then we'll pick up from here and keep going. I'll chat with you all then. Hey, so I saw a question in Discord, which was, did I miss the explanation of how to deal with jitter? Well, that answer be after the break. So a lot of this comes down to the process and the tools you're using. Those are the things that should be taking care of jitter for you, like this. And I noticed Bill jumped in. Thank you, Bill, and said, it's handled automatically in AC Hunter. We have somewhere around 30 patents on the way that we go through and we deal with jitter. And one of the reasons for getting the patents is so that we could put it in our open source tools, give it out to the community, and some commercial organization couldn't, patent them instead and say, no, 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 you must pay us, $5 billion to use this type of thing. So I'm not going to pretend that I'm the smart person that came up with the algorithms that we have. That's what my developers for. They're much smarter in this area than I am. But a lot of what we do is we go in and we look at it from two different factors. We look at it from a timing perspective, which is what we've been talking about. We also look at it from a repetitive session size perspective, which we haven't talked about yet. I'll get into that in a little bit. But we'll analyze it in multiple buckets. We do basically, I showed you that line chart or that bar chart over a 24-hour period of time and how you could draw a flat line across the whole thing. There's a multinodal patent that we just filed that deals with that when it's actually at multiple levels instead of in case it's hitting two different extremes. A lot of the work we do is kind of based on, it's kind of funny because most security companies, it's like, oh, here's a signature to catch that thing that infected you already. Sucks to be you. And they tend to kind of, here's how to catch the stuff we already know about. We focus a lot on what are they going to do next, right? If I was the bad guy and my stuff was starting to get caught, how would I change it to try and fly under the radar yet? That's where we live most of the time. The detecting things through a CDN, we implemented that years ago, right? And it's just starting to catch on now. But for years, we've been able to go through and catch that. To just kind of put it into context. So I mentioned Sunburst, right? So Sunburst, nation state attack, that was around 2020 or so. With both Rita, our open source tool, and AC Hunter, the commercial version at the time, both of those was fully capable of detecting Sunburst out of the box. We had customers in August that were detecting it. FireEye didn't announce it until December. So most tools gave you no detection ability until December. But in August, in July was when that code got pushed out to customers. Late July, early August was when we had people that were like, hey, so our SolarWinds server is now beaconing every 15 minutes out to an IP address in Europe. And SolarWinds doesn't seem to know why it's happening. They think it's some other software on our system that's doing it instead. So they didn't know what it was. They didn't know for sure it was a nation state attack, but they knew their SolarWinds server. This is new behavior. It's never done before. There was no legitimate business need for it. So our two choices are take SolarWinds offline or create a firewall rule that says, don't let this traffic out. And now, they're running an infected system, but they effectively killed the C2 channel. So there was no way to come in and kind of take over their box. So that should be done within the tool itself. Silly question, is it ideal to have Kali Linux installed on your host OS, both red, blue, and purple team? Kali's got a good set of tools. So there's a couple of operating systems out there that collect a bunch of tools together. And here's my spin on all of that. Those are great for learning. Those are great for getting exposure to those tools. They tend to be a little brittle. By that, I mean, someone or someones have tried to pull together a bunch of different tools that don't necessarily are designed to work together. And that can make things a little, how we say, unstable. I used to teach a class on Security Onion, and I stopped teaching the class just because we had too many stability problems with it in class. There were times that we would go in to analyze a PCAP, and half the class could produce results and the other half couldn't. And, the app that couldn't, the only way to seem to fix it was to reboot everything and go through the lab again for them. And it was a pain. Security Onion is an awesome tool. It gives you great exposure to a lot of really good blue team tools, but I'd never roll it out into production. I would say, so I've used a bunch of the stuff that's on Security Onion. Here's the 3 tools that I think are most effective in my environment, and I am going to deploy those in a production manner to make sure they remain stable. That's just my personal spin on it. All right. With that said, let's just jump right back into the content. So we've been talking about doing detection based on timing, but you can also do detection based on session size. And in fact, there's some cool things you can pull out of the whole analysis of session size. For example, think about what I described before, right? Compromised system calling out to a command and control server. Hey, do you have anything for me to do? Command and control server saying, nope, nothing in your work queue. Go back to sleep. It'll pause for some period of time. It'll check in again and do that over and over again. And then occasionally the attacker is going to throw a command into the work queue and that work will get executed. And then the data results from that command will get exfiltrated back out to the command and control server. Think about all that on a session size basis for a moment, right? So when it's calling out saying, hey, do you have anything for me to do? And it's hearing back, no, go back to sleep. That's what we refer to as the heartbeat. That's the system just checking in for work and there's nothing there for it. That's going to typically be a specific session size. With AC Hunter, if I go to view 2 on that top right hand of the beacon screen, and we'll do that later. Don't worry about jumping around just yet, but this is what the screen looks like. I'm going to see something like this. So here I've got a session size. Oh, I'm going to call that 80 bytes just to grab a round number. 80 bytes are getting transferred, and it happened over 100,000 times. Well, this is over 100,000 times means this thing's going off very frequently, right? It's going off more than once per second. Because once per second would be 86,400. So it's going off even more frequently than once per second. Well, nobody normally types that fast, right? No one's going to be submitting, a command less than once per second. So a majority of the time when this thing checks in, it's going to be told, nope, nothing for you to do, go back to sleep. That's my heartbeat. So this tells me nothing happened. Well, I've got 3 other sessions here that will larger in size. What does that tell me? That tells me something different happened, right? Instead of it checking in and saying, hey, do you have anything for me to do and being told no, go back to sleep, it was given a different answer. Whatever that answer was, run this command, do this check, I'm checking status, whatever it happened to be, resulted in a different amount of data being transferred. So in other words, if it said run the task list command, the session size is going to change to a value that would send that command down, right? So we've got some additional bytes from the command and control server telling the compromised system run the task list command. And then we're also going to see additional bytes leaving the environment based on the output of running that task list command, right? That's going to result in a larger session size. So one of the interesting things about session size analysis is not only can it be used to try and identify beacons in the first place, but it can also be used to identify, has this C2 channel been activated? And if it has, what's the attacker been doing? Now, here's one of the, can you tell me more about C2 over social media? I'm getting to that. Absolutely. That's going to be part of this section. So one of the, and that totally derailed my train of thought. Sorry about that. So one of the things that we run into as a challenge is that attackers tend to double encrypt things these days. They want to make sure you're not going to see the data that goes by. So what I tend to see is the malware will encrypt the data and then it will send it through, let's say, like an HTTPS session. So here's the problem. We've got a number of vendors that are selling outbound intercept proxies, right? They're selling these proxies as threat hunting tools that will allow them to try and pattern match on known bad patterns within your data as it's leaving your environment. So, you'll even see them being, sold to say, oh, well, if somebody sends out a spreadsheet, we will detect that. Well, yeah, if it's only wrapped in an HTTPS session. But if they're encrypting it and then running it through HTTPS, when you pull off that HTTPS session, what you're looking at is ciphertext. You don't know if there's a spreadsheet in there or not. I actually had an argument with one of these vendors that will remain nameless because, oh my God, this conversation was stupid. But the conversation was along the lines of them was like, hey, if you look at the attacks that are taking place, SolarWinds, another example of that, they're encrypting the data and then running it through an encrypted session. You're pulling that off. You've got ciphertext. You can't pattern match on it. And the argument I got back was that at least you're that much closer to the data. No, that's not how this stuff works. Do you understand encryption? It's not like binoculars, right? Where, oh, the binoculars are a little bit blurry, but if you tweak this, it's a little bit clearer. It's still not perfect, but it's a little clearer. You get a little better view. That's what they were arguing was the whole reason people should spend, $80,000, $120,000 for their tool. Forget the fact that it's a central point where you're decrypting everything, and that could be a security hell in a handbasket waiting to happen. But the benefit you get out of it is you're that much closer to your data, the data they're exfiltrating that is still just ciphertext. It's not like you pull off the first layer of encryption and you get to see the first two letters of every word. No, it doesn't work that way. It's still encrypted and still ciphertext. There's still nothing to pattern match on. So one of the challenges we run into is figuring out if the attackers use this channel, what have they done? Well, we can do some pretty good enumeration off of that just by looking at session size, right? So let's look at this environment. So imagine we're in doing a threat hunt. We're pretty certain their internal system's compromised. We do a session size analysis, and this is what we say. What is this telling us? It's telling us that it's overwhelming majority of the time, nothing happened, but 3 times something did. What's the largest session size here? Well, if I look at this scale, let's call it 300 bytes, just to pick out a number. 300 bytes was transferred. Okay, so what if that system has a 100 meg customer database on it? And our boss comes to us and says, did they get the customer information? Did they get a copy of that database? We'll look them square in the eye and say, no. Well, how do you know for sure? Because only 300 bytes got transferred. If they had said, copy that database, it would be 100 megs because that's the size of the database. If they said PK zip it first and then transfer it, okay, we'd still see at least 25, 50 megs, somewhere in that range getting transferred. We don't see that. We see 300 megs. This tells me somebody did a little poking to make sure this command and control channel was working. That's it. I would argue that this is telling us they haven't done anything yet beyond validate that this is actually working. So if we get them out now, like right now, we probably don't even have to disclose, depending upon the regulations, for the business vertical that we're in. But for most organizations, if we can prove they didn't get our customer data, we don't have to disclose that to customers. Here we can prove it. There isn't any transfers big enough to even transfer an account, a single account information type of thing. Let's see, there's a few conflicting instructions. Oh, that's in the fact. Okay, Bill will take care of that. So one of the questions was around C2 over social media. Social media brings a really interesting problem to all this, right? Let's talk Ukraine again. Right? When we want to look at what's coming down the wire and what are some of the worst things to worry about, we can look at what the Russians have done to poor Ukraine, because this is another one. So you may remember a number of years ago, Russia shut down their electrical grid. So they were able to get access to the back-end network for their electrical stuff and set up a C2 channel, and they were able to go in and start shutting shit down. How did that happen? Well, this will surprise you because it never happens this way, but somebody clicked something they shouldn't have. Somebody opened up a spreadsheet and the spreadsheet said, hey, you're running an old version of Microsoft Excel. Click OK to enable macros to convert it, so you can read this document. And that sounded plausible to the person, right? Because, honestly, who keeps track of what version of software they're running these days, especially when you get into something as benign as like the Office Suite stuff? Who knows? I stopped keeping track at like 7. Who knows what version they got running now, and who knows if it's old or new or whatever the case may be. So somebody looked at that and didn't stop and think about, well, what else might those macros do? And they clicked OK. And when they did, that got their system infected. And what the malware did is it would call out to a Gmail server and it would check a specific email account to see, do I have any messages? Because if I do, any email I get, I'm going to try and process that as a command and control command. So now, in order to send command and control messages to this compromised system, literally all you needed to do is email an account. So you'd email the account and say, run the task list command. And then you would get an email back from that account saying, here are those results. And you could just go through and do it that way. Now, the problem is you can't catch that based on timing because their little, portable Gmail account, Gmail client was checking email every 10 to 12 seconds. Well, Gmail does that anyway. So it doesn't look any different than the other tools that are out there. And this is our biggest problem with social media is that if we're allowing connections to social media from our corporate environment, anytime social media is used as a command and control channel, it's going to look from a timing perspective exactly like legitimate traffic. Now, where it might look different is based on the session sizes. For example, the average business user sends and receives about 113 email messages a day. And that's 113 email messages where maybe the email is just one sentence, maybe it has an attachment, maybe it has a string of messages that are there. It's about 113 different session sizes that you might see pop up. If I have a command and control channel running and nothing's happening today, I'm going to see the heartbeat and I'm not going to see any other session sizes show up. I'm going to see some number dramatically less than that business average of 113. Now, this could be someone who just doesn't get email. It could be an account that doesn't get email. That's entirely possible. So the false positive rate goes up exponentially. So in an ideal world, what's the best way to deal with it? Anything that could be a potential conduit like Gmail, tell folks, nope, can't use it. That's, you want to check email? Great. Use your cell phone and connect up through your carrier and you can check your home mail that way. Don't do it over the corporate network. That is the most consistent way to deal with the problem. Now, if you can't implement something like that, let's say you've got lots of traffic going out to Gmail or LinkedIn or, pick your social media of choice. Now you need to kind of figure out what is the normal for average usage. Do I have anything that deviates off of that? And it takes a lot more work to go through and find it. So for me, I don't really go down that road. And we do have some tools built in, or we do have some math built into the back of AC Hunter that does session size analysis to go looking for that type of stuff, but it's not perfect. It's not as good as, hey, this is going to Guangzhou, China, or hey, this is going to some domain that, isn't normally associated with what you do business with. It isn't going to be as accurate as that, but at least gets you something. So safe listing. So I mentioned, just because something's persistent doesn't necessarily mean it's evil. Let's pick on network time protocol, NTP, or a simple network time protocol, which is what Windows uses. So Windows will check to see what time it is every 30 minutes. Most Linux, Apple, Unix-based operating systems, depending upon the platform, it's going to be every 15 minutes or it's going to be every 20 minutes. So a couple times an hour, our system's going to go check to see what's the current time. Has my clock floated? If so, I'm going to go and tweak it back in again. That is a typical business. That's a legitimate business need, right? We got to keep our systems in time sync. So if I see that, I'm going to want to create what's referred to as a safe list entry for that. A safe list entry is just simply, hey, yes, I recognize this is a persistent session, but there is a business need behind it. I want to remove it from hunts that I do in the future. And as I said, the first couple of times you go through and do your hunts, the first 3 or 4 times, you're going to find a ton of stuff like that, right? With the commercial version of AC Hunter, we ship a default safe list that I think is up to, 80, 100 entries, somewhere in that range there. I forget the exact number, but there's a lot of them. I know there's like 5 or 6 pages of them once you load it up. But that is to clean out all the common business stuff that you might run into. Now you got to be careful doing safe listing, right? You don't ever safe list the IP address of a content delivery network. Why? Because multiple entities can exist behind that. Not just the good one that you're okay with right now. A bad person could locate something behind that same CDN network. And now you've just gone in and said, hey, that's okay. So you got to think through when you go through and you create a safe list. But this is one of the most powerful tools you have for removing the stuff that's okay, getting it out of the way so that you now have full visibility of anything new that pops up. Anything new is absolutely worthy of further investigation. Identifying business need. So, like I said, well, a lot of this can just start with, do you recognize the domain? Right? Those first three in the bullets, everybody ought to be able to look at the three and say, yeah, I can understand why my systems might be connecting to each of those. If you can't identify the domain, now you need to kind of run down, okay, is there a potential business need while we might be connecting to this? So one of the things I'll do is I'll investigate who's the organization behind this IP address, right? Example.com. Who are they? What type of service do they offer? Um, that whatever service they offer might help point me to the right internal group that might be leveraging that service. At the end of the day, the purchasing department should know about all of these, right? If we're connecting out to foobar.com, and they offer widget services or marketing services or whatever, I should be able to go to the purchasing group and saying, hey, do we have an open PO with foobar.com? If so, who created that PO? Oh, it was Tim in the marketing team. Great. Let me go talk to Tim. Let me find out what's going on with that. So, this is one of the most non apparent but best ways I've found to be able to go in and run a lot of this stuff down. But we can also look at things like, who manages that ASN, what domain has that been allocated to? A lot of that stuff could kind of help you run this stuff down as well. There's also a bunch of third-party websites that can give you some really good information. Virus Total, that's one you probably recognize. You can go through and you can use that. Alien Vault and Abuse IPDB have some really good information in them as well. So I can go in and I can take that IP address or fully qualified domain name that the user was talking to, feed it into their database to say, hey, what do you know about this? And that could be whether other people have reported as potentially being evil in the past. It might just be additional information about, hey, here are fully qualified domain names that have resolved that IP address in the past, and this is the dates that it happened on. And here's the organization that's behind that. All right. So once we identify persistency, and once we've kind of done a peripheral check and said, I can't find a obvious business need that would require this persistent connection to take place, what do we do next? Well, we said our next step is a protocol analysis. Our next step is to say, okay, let's take a deeper dive on this communication to figure out, does it look legitimate, or are there clues or hints in it that might tell me somebody's bending the rules and maybe this is actually something evil? So, one of the first obvious things to go in and take a look for is those ports that should just not be being used, right? Things like Chrome Remote Desktop. You shouldn't be seeing that leaving your environment. If you are, that's a potentially really bad thing, unless you're, purposely using it internally, type of thing. So again, you can go in, you can kind of run some of these down. Unknown app on a standard port. So don't get this wrong. I'm not talking about someone decided, hey, when I run SSH on port 22, its default port, every script kiddie on the internet starts trying to break in. And I start getting tons of failed logins showing up in my logs. And I don't want to have to sift through all that garbage. So I'm still going to do everything I can to lock down SSH and keep it secure, but I'm going to move it to an alternate port that the script kiddies might not know to look on, like port, I don't know, 2222 or something like that. I'm going to put, instead of being on port 22, it's going to be on port, 2222. And now script kiddies won't go looking there by default. Some people might find it. And if they do, yeah, I'll see some failed logins because of that. But seeing those failed logins means more to me now, right? When it was on port 22, any script kiddie with a computer could be running some software they downloaded from anywhere and beating on my door. So the fact that they're trying to break in over SSH tells me nothing about them. But if they found SSH on an alternate port and tried to do a legitimate SSH login, oh, now I know they're a little bit more advanced, right? Now I know if this is not someone if it's not someone who is allowed to access that legitimately, I need to be a little bit more concerned and up my game because they've got a little bit more going on. They're going to be a little bit more of a higher level adversary. Just because you see SSH going to port 2222 doesn't mean it's something bad. right? So that's what I mean about if somebody's running an app on a non-standard port, don't worry about that from a threat hunter perspective. It's perfectly fine. There might be a network usage policy break there. Who knows? Depends on your organization. But from a threat hunting perspective, we don't care. What I care about is its traffic going to TCP port 80, but there's no user agent string. There's no refer. There's no URI field. There's none of the things that are normally associated with the HTTP protocol that is normally using port 80 by default. If it's some other protocol, that's somebody trying to tunnel something that you need to be worried about. If I'm looking at TCP 443 traffic, which is normally SSH, excuse me, it's no, yeah, SSH. It's normally TLS. So I expect to see an SSL client hello go by. I expect to see an SSL server hello go by. I expect to see the server send its digital certificate. And that happens in the clear. I should be able to see that. I expect to see that take place first over TCP 443. If I don't see that, if I see anything else but, that's a problem. That's somebody trying to tunnel data out through that port. If all I see is what looks like ciphertext and that's it, nothing else, well, that's clearly not a normal TLS negotiation. Something else is going on here. I have to go in and pay attention to that. And one of the nice things about Zeke is Zeke comes out of the box understanding about 55 different protocols, 55, 57, they're somewhere up in that range right there. And it's all the normal protocols. So the things it might not be able to decode yet are things like net BIOS over IP. Oh my God, I hope you're still not using that, right? So it may not recognize that, but that's okay. We shouldn't be passing that over the internet anyway. But the stuff you normally use, HTTP, HTTPS, DNS, those protocols it understands. So that'll help you figure out what's going on. Most tools, when it sees traffic going to like TCP port 80, it will label it as HTTP. It doesn't mean it actually did a protocol inspection. It's just saying, well, most traffic over TCP 80 is HTTP, so this must be HTTP. No, I'm sorry. Those are not subsets of each other. That's not how this works. Anybody could be pointing anything at that port. You've got to decode it from an application level. And that's one of the things Zeke will do. So when Zeke tells me that the traffic coming from this source IP address, going to that destination IP address, going to that destination port, TCP port 80, was HTTP, it's not just because it's TCP port 80. It's because it saw all of that stuff I described that is normally passed back and forth as part of an HTTP negotiation. Notice the second line, it doesn't label it as HTTP. And that's because it didn't see that header information go by. Well, wait, Chris, does that mean somebody's doing something funky? Not necessarily. Notice the number of bytes going by here. This looks like someone tried to connect up to a port and it didn't happen. Right? The port's closed. It got rejected for whatever reason. This looks like it's just a connection that never got through the TCP3 packet handshake in order to be able to then transfer the information normally associated with the HTTP negotiation. So that's why it didn't label it as such. But Zeke understands protocols. Definitely leverage it. So AC Hunter will display this for you. So typically when you're looking at a communication session, right? So this is showing the destination IP address and all the information that's associated with that IP. You're also going to see on the COM line, TCP SSL. Now, that doesn't mean it was SSL. Zeke generically refers to SSL and TLS as SSL. It puts them all in that same one bucket. And that's fine. We know that this is the traffic we expect to see on TCP 443. Now, if this said SSH, I'd be worried. If it said HTTP, I'd be worried. If it said dash, I don't recognize that protocol. Again, I would be worried. You can also see attackers bending the rules. So they're not actually breaking anything, right? But the protocol is just, you're seeing data that's not consistent with how it's necessarily used. And a great example of that is what happens when you're looking at C2 over DNS. So in the previous examples, when we talked about C2, I was showing you a connection that was originating from the compromised system going out to a system out on the internet. So one of the things I could potentially do is monitor at my perimeter, monitor at my firewall to see, hey, this system I think might be compromised. is it sending any suspicious looking traffic out to the internet? And I might be able to pick up on this command and control channel. One of the things that's really insidious about C2 over DNS is that no traffic leaves the system going directly to the internet. It relays it through whatever you're using for DNS servers. So here's how this works. The attacker says, okay, I'm going to do C2 over DNS. So I need a way to tell people where my C2 servers are so that when I compromise that host, they can create a connection to that C2 server. So what they do is they register some domain name. For the sake of example, let's use evil.com. So my attacker goes out and registers evil.com. And when they do, they need to identify what are the what are the authoritative name servers for that domain. Well, the servers they list are their command and control servers. So now what happens? Someone clicks something they shouldn't have, right? The malware, instead of doing a direct connection out to the command and control server, does a lookup for a resource record within that domain. That goes to the local resolver. What's that resolver do? That resolver does all that work to figure out where this system is located and sends that DNS query to that system. This is code to let the command and control server know, hi, this is me and I'm in a compromised state. The answer that comes back to its question is going to be its marching orders for the command and control server. So this might be its way of saying, hey, I'm here. Do you have anything for me to do? And the answer that comes back might be, nope, go back to sleep. Or it might be, run the task list command, run the dir command, whatever the case may be. All of that happens over DNS traffic. That's it. Now, one of the side effects of this is I end up with more unique resource records being queried within a specific domain than what logically makes sense. What do I mean by that? So think of your average DNS property or your average domain property on the internet. What DNS records do they need? Well, I've probably got a web server, so I need one for that, right? I need a record for my mail server. I got a couple of DNS servers. Maybe I got a customer portal. Hey, look, we're still counting fingers on one hand, right? That's 5. They don't need many. Maybe a DKIM. Okay, that will bring out a finger on the second hand. We're now up to 6 records that your typical domain might need. But it's 6. It's a small number of unique resource records. Now, there are some environments, like Akamai is a great example, where that number might actually be a lot higher, right? Akamai is the biggest content delivery network in the world. So they're going to have multiple CDN servers available in different geographical locations all around the world. So you might actually end up talking to a couple hundred different Akamai.com systems. And that's expected. But you probably already knew who Akamai was before I told you. Same way you know who Google is, Amazon, Microsoft, or any of the domains where you might actually see a couple hundred resource records. But for the ones you don't recognize, 10 or less. Well, now we can go in and we can look at, okay, if I don't recognize the domain, it should be about 10 or less unique resource records. Let's be really generous and call it out at 20. So I should see 20 or less resource records. If I recognize the domain, it needs to be 1,000 or less, right? And, so now when I go in, I'm going to look at what is that domain? Okay, this domain is r-1x.com. Okay, I've never heard of that before. So that drops us into that first bucket, right? I should have 20 or less unique resource records. Well, this is saying we looked up 62,468 unique resource records. What? That makes no logical sense, right? Who is going to expose that many resource records to the internet? That makes no sense at all. So, I'll show you this right within the system, right? So on the main dashboard, I can see it saying 2 potential C2 over DNS cases detected. So I can go to my DNS module, and when I do, hey, here's r-1x.com with 62,000 plus unique resource records. This is the number of queries that was done. I don't care about that number. That's a popularity contest. I don't care about a popularity contest. What I care about is unique resource records. My second entry, well, that's just a subdomain, right? So these two are really the same. It's the same domain for both of them. It's just one of them is a subdomain within it. We said 20 or less, that's 62,000. There's a big difference between those two numbers. Yeah, this is probably worth going in and taking a look at, especially when I start looking at things like, Akamai, his Akamai Edge, 154 systems. Okay, we said 1,000 or less. 154 is less than 1,000. 125 for akadns.net. Okay, that looks okay. Everything else, Amazon AWS, 101. Oh, that stuff looks fine, right? So the first thing we're noticing that's odd is that way more resource records being exposed than makes logical sense. They're not breaking the DNS rules here, but this is odd behavior. This is outside normal behavior patterns. The other thing we can look at is utilization. So, for example, picking a normal one, akadns.net, we said there's 125 resource records that we resolved within that domain. There's data over here on the right. What this is telling me is I had 3 internal systems that did DNS queries within akadns.net. Well, if these are my 3 internal resolvers, that makes perfect sense, right? Because of these 13,000, almost 14,000 individual queries for 125 different unique resource records, that resulted in 19 of my internal systems connecting to one or more of those 125 resources. In other words, this is kind of what we expect for DNS, right? User types a name in the browser, hits enter, DNS resolves it to an IP address. We connect to that IP address within that domain. So this is what we expect. This is normal. Now, if I go back up to that first record, what I see is that I had one system doing DNS queries, but more importantly, that's the only system accessing resources in that domain. In other words, we looked up 62,000 plus resource records, but none of our users needed to access any of those resources. Oh, that makes no sense at all, right? That makes absolutely no sense at all. If I go in and I look at like if I look at Amazon, right, 101 resource records, 3 systems resolving it, and I had 14 different systems connecting up to multiple resources. That's what we expect to see, but that's not what's happening in this first record. So we can see, again, they're kind of bending the way the protocol is being used. That's something that makes it worth interesting. That's something that makes it worth doing a little bit of a deep dive. So that's the bonus check on DNS that I was talking about. Go in and look at, are we, if we're looking up a lot of resources, are users actually accessing those resources? If so, we're probably fine. If not, whoa, warning, Will Robinson, we got a problem. Okay, let's talk about this command. So what I'm doing here is I'm working with Zeke, right? Zeke will create a bunch of different log files. I can show you that real quick. So all of the labs are going to be in the labs directory. Ooh, hey, that's some creative thinking, right? I put the labs in the labs directory. And you'll see there's 3 of them. We'll do the first, then do the second, then do the third. And I'm just going to CD into the lab1 directory for now. And I'm just going to take a look at what files are in there. All of these .log files that you see, these are all Zeke log files. The main one is this one, con.log. Con.log gets a record for every communication session that takes place on the network, regardless of whether it's TCP, UDP, ICMP, whatever the case may be. So there's a summary of everything in that. If the traffic was based on DHCP, it's going to make additional records in here. If it's based on DNS, guess what? Guess what? DNS.log. Hey, what do you think is in NTP.log? Ooh, what do you think is in SSL.log? You get the idea, HTTP.log, you get the idea. So anytime it understands the protocol, it puts it into a file that is identified by that protocol. How do I map those two together? In other words, if recording some stuff to con.log and it's recording other stuff into HTTP.log. How do I tell the difference between the two? It's because of this field right here. This is my unique ID. This is that is a unique record for every connection that takes place. So if I go in and I just say, hey, let me copy that field, and now I'm going to say grep that field star search everything, notice what comes back. Here's its entry within con.log. And the traffic was HTTP traffic. So it also made a record in the http.log file. And here's the information that's in the http.log file. So all of that gets recorded right in there. Pretty straightforward. Wrong command. Yeah, you're not on Windows, Chris. That's okay. So that's what all of these log files are. Just wanted to show you that real quick. We'll get more into using those later. So here I'm catting the http.log file. And then I'm using a tool called Zeke. We'll talk more about some of the tools you can use in just a little bit. Zeke is my way of saying, I don't want to look at all the data in this file. There's only certain pieces of data that I want to go in and look at. So to go back to what I was showing you a moment ago, I go in and go back to this command. All of my columns have titles on them. Spread this out a little bit. So here's my unique ID. See this here? That means source IP address. Original _H, original host is my source IP address. Let's see. Here's my original port. So that's the source port. Next is my destination IP address. Here's my destination port. Protocol, what was the service that was identified? How long did the connection last for? How many bytes left the source system going to the destination? How many bytes came back from the destination going to the source? You get the idea. All of these columns have different titles associated with it. So I can go in and I can use Zeke to say, don't show me all the data in that file. These are the only fields I care about. And what I said was, show me the source IP address, the destination IP address, the user agent string, and then I'm grepping for one specific internal IP address that I'm interested in analyzing. Then I'm saying sort unique. What that's going to do is it's going to allow me to identify what user agent string was used against each of the different target IP addresses. And here I'm going to go through and cut that information out and then resort it, unique-C counts it. And that's going to identify how often was a specific user agent string used per IP address. And then I'm saying sort-RN. So here's the results here. What does this results tell me? This results tells me that for 15 different IP addresses I talked to out on the internet, this was the user agent string that was used in that HTTP session. For 12 different IP addresses out on the internet, this was the user agent string that was used in that HTTP session. For one IP address I was talking to out on the internet, this was the user agent string being used. Notice the disconnect here. For 27 different IP addresses out on the internet, I identified myself as being a Windows 10 system. When I spoke to this one specific IP address, hi, I'm Windows 7. No, or excuse me, Windows XP. No, that's not how this works, right? Windows doesn't go into like camo mode or something weird like that. No. Now, this could be, somebody's running a Windows XP VM and they're connecting out to this one IP address. That's possible. What's the likelihood of that? Well, think of it this way. When's the last time you did that? Probably not that often, right? and if you did, it was probably part of a forensic analysis or a lab or something like that. This is not something that happens in normal business. So this is something that I would flag that, if I saw beacon activity taking place and I notice that during the beacon, it identifies itself as being Windows XP, but for every other IP address it talks to, it identifies itself as Windows 10. Oh, that's a problem. That's something I need to go in and pay attention to. And you can do the same thing using JA3 hashes with HTTPS. JA3 hashes are just simply a hash of the start of that SSL TLS session. But you can use that same type of thing to go in and look for, because you can map these hashes to different operating systems. So I can go in and say, hey, does it normally identify itself as Windows 10? But sometimes identifies itself as, Windows XP, Windows 7, or some completely different platform. If so, that time it's identifying itself as being a different platform, I may want to zoom in on that. once we go through and do a protocol analysis, now we want to go in and take a look at that internal host. And remember the rules. The rules are don't cross the passive active line. So this doesn't mean next I'm going to start touching that system. This means next, I'm going to see what I can see about that internal host. Maybe I set up a packet sniffer, right? Maybe if I set up a span port to that one system and I start capturing all the traffic that comes out, or I run Zeke to capture all the traffic that comes out. Maybe I go through and I say, hey, do I run something like Carbon Black? What does Carbon Black know about this system? Do I have a SIM? Am I doing any logging off of that host? If so, what do those logs have to say? If I don't have any of those tools, can I run some, passive fingerprinting tools or stuff like that to be able to collect data off of that system that might help me figure out what's going on? I'm going to focus on the internal system, but do it in a way that if that system is compromised and the attacker is watching the console, I'm not going to be reveal to them that I'm onto them owning that system. So like I said, this is a great time to leverage that internal host log and do it in a way that's not going to generate false positives. In other words, if we're alerting every time, we see PowerShell, show up as a text string, we're going to miss anything that's not PowerShell, and we're going to get false positives when PowerShell is being used legitimately. But in this case here, we're seeing persistency out to the internet to an IP address we don't recognize, that we see no official business need with. And if PowerShell is creating those sessions, oh yeah, we got a serious problem we got to worry about. But sysmon is a great way to go in and collect that information. So I can use sysmon to go through and collect what's referred to as ID3s. ID3s are just applications communicating on the network, and here's all the type of information that an ID3 reveals. And as I mentioned, Beaker is our system that's designed to use that and WinLogB to collect ID3s off your endpoints, so that if you get into a position where you're seeing persistency coming from an internal host, you've got a way to go through and run that down. Now, in this case here, we can see, hey, when this IP address was talking to that IP address, we can't see the date time frame, but that's okay. But when this IP address was connecting out, it was Notepad running on this system connecting to that IP address. Oh, okay, good. It was just Notepad. Oh, no, wait. Notepad doesn't talk on the network. Notepad has no reason to be connecting to, I believe that's a DigitalOcean IP address. That makes no sense at all. Something's wrong. This is not the Notepad we think it is. Now, again, would you ever write an alert in your SIM to say, warn me if anybody runs Notepad? No, of course not. It's going to false positive like crazy, right? But here we have context. The context we have is this application is causing connections from this system to that system. In that context, I know this is not the Notepad I think it is. Something else really weird is going on here. Time to hit that big red incident response button. Something's up. PowerShell, another great living off the land tool. Yeah, absolutely. Absolutely. And some places I've noticed will write a similar to say, hey, anybody runs PowerShell, let me know. And then, inevitably the IT team will use PowerShell to do something on every endpoint as part of, modifying policy or something. And then all of a sudden your SIEM's alerting and lighting up like a Christmas tree. I hate it when that happens. But I have no system logs. Well, this might be a really good justification for making sure you start collecting. And what next? Like I said, now that we've done all of our investigation, it's three possibilities. Now that we've gone through all our threat hunting steps, we have three possibilities. Possibility number one, I can identify an associated business need. This is okay. When I went in and looked at what the application was, it told me it was Slack. And we use Slack internally, so I know that's okay. So I'm going to create a safe list entry for that. That's one of the nice things about seeing what app is causing the connection. It can help you run things down. So possibility number one, I know it's okay. I'm going to safe list it. Possibility number two, I know it's not okay. I need to hit the big red incident response button. Notepad is connecting out to DigitalOcean. We're going to have a really bad day, probably a bad week. And if things go really sideways, we're going to have a bad month, possibly a bad year, right? Something is horribly wrong. The third possibility is I'm still not sure. That's not a valid choice. If you're down to that third choice, you're not sure, your next step needs to be, what do I need to do to figure it out? Right? Maybe we're not running sysmon to collect anything. Okay, maybe we need to do that. Now we're crossing the passive active line if we go log into that system and install syslog, right? Or sysmon. But now we're kind of at a point where we're out of options. It's that or nothing, right? It's either that or we say, well, we're going to nuke the system just in case, and maybe we didn't have to. We're kind of at limited options at that point. Don't get yourself into limited options. All right. And with that said, let's take a break. So it is the top of the hour. Let's see, for an org with mostly remote endpoints, what are some suggestions for log capture tools? Azure Sentinel is a viable option. Yep, that it is. You could use system window logs. They're working on a Zeke client for Windows, although that's still very much a beta. You have to actually compile it yourself. That's another option. I kind of like sysmon. I kind of like the ability to go in and kind of vet things based on that. That's one of the possibilities. And you can use a tool like WinLogBeat to throw that into an elk stack or a SIM or wherever you want to send it to. So that may be a possibility for you too. Splunk, yep, is another option. Absolutely. So with that said, let's take a break. 10 minutes after the top of the hour, we will pick up from here and keep going. All right, we are back. So Keith mentioned SB. Yeah, that's another open source project we run. SB is kind of like Beaker, the one I described earlier, except it also does beacon analysis. Beaker is just designed to collect those ID3s and identify what apps are, talking on the network. SB does that plus go through some math to figure out, is there any persistency of connection here that you might want to pay attention to? So for an endpoint that's not behind your network, yeah, SB is definitely a better way to go. Screen said sysmon plus WinLogBeats plus security onion. Totally agree, but I will defer to my comment earlier about security onion in a production environment makes me nervous. There's a lot of code running on that was not designed to work together. I've just seen a ton of stability problems with security onion in the past. So I would do that setup to test it. And then once I liked it, now I would go through and do a production setup where maybe I run a system just dedicated to running an elk stack. I'm less likely to run into any types of trouble. I'm really, really new when it comes to threat hunting and blue team in general. My question is, can we run this on our own networks? Absolutely. I just started to spin up a VM and red machine that would attack another machine. Could I capture it? So this isn't going to so what the processes we're talking about aren't necessarily to catch an attack, right? You'd want to look at like a network-based intrusion detection and prevention system or something along those lines to look for, something malicious coming inbound type of thing. What this is designed for is you tried to do that and you missed it, right? And you ran an endpoint security agent and it missed it. And all your levels of protections missed it. And now you're compromised. The clock is ticking. How long is it going to take you to figure out that your layers of protection failed? That's what this is designed to go through and do. I was pronouncing it eSpy. Yeah, dude, it might be eSpy. I'm not sure. I've seen both from the development team. They were the ones who named it. Sorry if it doesn't make too much sense. It made total sense, dude. I missed this part. What database are we coming here for? So we're going to actually create the databases we're going to go through and use. The one on the bottom, the DNS Cat2 J3 Strobe, I'll be doing a walkthrough with that one in just a little bit. But we'll actually be importing data in and going through that whole process and using that. All right, let's get back to it. So network threat hunting tools. So what I wanted to do in this section here is just give you a quick primer on what tools are out there, which ones may be able to be helpful to you as you kind of go through and, excuse me, when you go through and you start trying to do your threat hunting process. And one of the ones you kind of always have to talk about is TCP dump because it's been around forever. Everybody uses it. Any of the old timers know how to use it. It's just kind of been there. I grew up on TCP dump. With that said, I'm not a big fan of that for this type of work. And the reason is it's designed to work with PCAPs. And it's very limited in what it's capable of doing. It's not like T-Shark where I can go in and I can say only print out certain fields and stuff like that. But what it is good for is actually capturing those PCAPs. So if you need to, if you're going to create raw PCAPs rather than just run Zeke. It's one of the easier tools to go through and do that with. Here's a script written by our illustrious Bill Stearns to go through and create that for you. So what this would do is this would create a directory that this will store PCAP files to. And what it will do is every 3,600 seconds or once per hour, it will write a PCAP into that directory. It will name it with the name of the host that this tool was run on, the date timestamp, so you know what hour that data was collected during, and then it'll even go through and compress it up. PCAPs don't compress a lot, but hey, with this type of thing, any space we can save is worth it type of thing. T-Shark is the command line version of Wireshark, right? So most of us are familiar with Wireshark. Think of it as like Wireshark on the command line, if you will. What I like about Wireshark is it does let you go through and extract out only certain fields. So I can go in and I can tell T-Shark -T capital fields. That tells it don't print out a summary, only print out what I tell you to. And I can go in and use display filters to identify which things I want to print out. So if there's certain things I want to focus in on, I can go through and do so. You saw me do that a little bit earlier with the Zeke logs, where I was saying, hey, I know you get a lot of great information in that .log file, but these are the only fields I'm actually interested in processing. You can go through and do the same thing with T-Shark. And I've got a couple of blog posts up on working with T-Shark and how to manipulate these fields and some of the cool things you can do. But I gave you a couple of examples in here. In this one, we're going in and we're just looking at what are all the DNS queries. And here we can say, these are odd names, right? Would you choose to name a system that? Probably not, right? That doesn't make a lot of sense. This looks a little off. Let's see here. I'm going in and I'm pulling out the user agent string. And then we're looking at, what user agent strings are being used on the network type of thing. So there's all sorts of stuff you can pull out with T-Shark. CapInfos is a tool that ships with T-Shark. CapInfos is a great way to get a quick summary on a PCAP file. So imagine somebody came in and said, hey, I think we might have some C2 on our network. Can you take a look at this PCAP file for me? The first thing I'm going to do is run CapInfos against it, because that's going to tell me how long was this capture run for. And if the capture was only run for like 5 minutes, sorry, I probably can't help you. A 5-minute capture isn't going to help me run down connection persistency. Any connections in a 5-minute period of time mean nothing. Now, if this is 12 hours, 24 hours, now I can help you run down some connection persistency if it happens to exist inside this file. This is one of the first things I'll always do anytime I get a PCAP. Wireshark, most of us are familiar with this. A lot of us like to use this tool or have used this tool. I like Wireshark. The limitation of Wireshark for me is that it's really good when you've already filtered out some of the noise using some other method. In other words, using Wireshark only is very cumbersome. If I go up and I try and load a PCAP, one of the first challenges I run into is it's got to load the whole damn thing in RAM. Well, what if it's a 10 gig PCAP and I don't have 10 gigs of memory free? Well, now we're going to start swapping disk like crazy. It's going to take forever for this thing to load. It's going to take forever anytime I want to go in and make any changes. Whereas I could do the same thing with something like T-Shark and be a lot more efficient at it. Or I could do the same thing with Zeke logs and be even more efficient than that. So Wireshark is fine when it's, oh, hey, I have this connection pair I want to do a deep analysis on. I find it as a really good tool for that. But if it's, hey, I'm just doing a hunt in this PCAP for the first time, I'm not going to start with Wireshark. Zeke, I've talked about this. Zeke is an awesome tool. I cover this extensively in my advanced class, but I wanted to at least kind of give you the highlights here. It doesn't give you real time, right? Zeke goes through, and what it will do is it will watch what happens on your network for an hour, and then it will write out those log files. And then it'll watch what happens on the network for an hour, and it'll write out those log files. So going through the logs, you're always going to be about an hour behind. But what I really love about this tool is that it makes it very quick to search for things, to sort things. It allows you to take very large networks moving a lot of data Yeah, I've seen networks that are pushing, close to 100 gigs that are using Zeke to go through and keep track of what's actually taking place on their network. And here's an example. So here I'm saying cat the SSL.log file. I just typed star because I guess .log was too complicated for me. Whatever. There may have been multiple SSL log files in this directory. So what I'm saying, cat this file, which would normally just display all that information on the screen. But instead, I'm saying pipe that through Zcut. And I want to print out the source IP address, the destination IP address, the destination port, the validation status, and I want to grep for self-signed. What am I doing here? One of the cool things you can do with Zeke is you can tell Zeke, check the validity of every digital certificate on every HTTPS server that anybody talks to. That's kind of cool. Actually, it's not just HTTPS. It could be, you know, TLS over SMTP over TLS. It'll check those too. So basically, anything using SSL TLS, it'll go through and verify the digital certificates for you. The only time I've ever run into a problem with this is Microsoft has started self-signing their digital certificates for some of their backend servers. They're not using a third-party verifiable digital certificate. Why? Well, because it's Microsoft. They're a trim, lean company. I think they've 50 employees, maybe 55 now. They're always running on a tight budget. I mean, third-party digital certificates are expensive. I mean, that's like $125. That's probably what they pay an engineer for a whole year to work at Microsoft. So yes, I'm being totally sarcastic with all of this. To me, there's no legitimate reason for what they're doing. They can get away with it. That's why they do it. So what they're doing is they're saying, well, Windows systems are the ones checking into these servers. So we'll just put a root certificate on the Windows boxes and say, go ahead and trust it. Don't worry about it. And now they won't get any type of an error. But if you try to connect to that same server from Apple, Linux, BSD, any other operating system, it says, yeah, I don't recognize this digital certificate as valid. I don't recognize the certificate authority who signed this. You can change that if you want to. Zeke uses the local certificate store for Linux. So if you want to add that digital certificate in manually, you can. That's the only kind of gotcha I've run into with this. But if you want to kind of keep track of like who's using self-signed certificates or who's talking to a server with an expired digital certificate, Zeke will give you that type of information. I felt only slightly triggered as ex-Microsoft. Awesome. Of course, there's a command line version of Wireshark. I'll have to drop this down for personal use. Oh, yeah, G Brown. T-Shark is your friend. Trust me. And I got a couple of blog entries where I gave some examples. It's up on the Active Countermeasures website. I think one's called like Jump on the T-Shark or something like that. There's some really cool stuff you can do with that tool. I'm teaching a packet decoding class soon. One of the cool things we do is we use T-Shark to extract a C2 session, I think running over, I think it's one running over ICMP or something like that. But it's also been encoded. And then we run it through another code tool to decode it. And T-Shark will let us extract out only those bits of information we actually need. We can then decode it and see everything that was actually happening over that C2 channel. You can do some really cool stuff with T-Shark. Zcut, if you tell it you want to print out the timestamp, it will normally do it in, the Unixy format of how many seconds have gone by since, January 1st, 1970 or whatever. It's going to print everything out in epoch time. If you want to see normal human dates and times, you can use the -D switch. Just, keep in mind you lose some resolution with that, right? It's easy for me to see based on the decimal number here that these, which sessions happened in what order. I lose that visibility here. So just keep that in mind if you do go through and use the -D switch. And Just Ben, you said, Jinx, buy me a Coke. No, 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 I'm sorry. The correct statement is sudo buy me a Coke. All right, another cool tool. So this is one we offer up as well. This again is from our illustrious Bill Stearns, Zeke. So Zeke is like Zcut, but better. So one of the challenges with Zcut is it only works with CSV formatted files, with everything in the little columns like I was showing you. Well, one of the problems with that is Zeke also supports JSON format. And some of the tools that you import Zeke logs into want it to be in JSON format. So you might have to use that format. Well, normally what you'd have to use is use a JSON manipulation tool. And oh my God, it's a bear. It's a pain. I don't teach that in my classes because I have trouble getting it to work consistently and have trouble to have people not make simple mistakes like a space in the wrong spot, or you put two spaces there instead of one and now everything blows up. And it's a pain. Zeke takes care of all that for you. So the Zeke logs can be in CSV, JSON, or both at the same time, and it'll work perfectly fine. Go through and parse those, no problem. So this is a pretty cool tool. There's a link for it down at the bottom. Keith also posted a link. Yeah, definitely a cool tool. I'm going to integrate this into this class for the next time I teach it. Another tool from Bill is Passor. So this is a nice passive monitor the network and see what you can learn type of tool. It's designed to kind of give you some insight beyond just generating PCAPs and trying to figure out what's actually going on in the PCAPs. So you can see here, Passor is going through and identifying, hey, this internal system, here's who it's talking to and what application it's using. Here's what ports are open on it. Here's some of the interesting stuff going by on the payload layer. So if I know nothing about my internal systems and I'm trying to do a threat hunt, it might not be a bad idea to run Passor for a little bit and see what Passor can tell me about that internal system. That might make running it down a little bit easier. Smudge is another tool, open source tool we have. By the way, all those tools are free that we have. They're not a commercial charge for any of them. But Smudge is another. So for the old timers, you may remember P0F. P0F was a passive fingerprinting tool. It allowed you to identify what operating system was sending traffic. It did that using nuance information that would be inside of the TCP SYN packet that allows you to distinguish a Windows system versus a Mac versus, a Linux system type of thing. But P0F stopped getting maintained. We've kind of re-upped that with this new tool, Smudge. So Smudge will allow you to go through and do passive fingerprinting on things. That might be a good decider, right? Like if I'm seeing somebody identifying themselves as Windows, if the packets claim to be a Windows 7 system, but I do a passive fingerprint, the passive fingerprint says, no, you're Windows 10. Oh, that's a problem, right? If my application layer and my TCP layer don't match on what they're identifying the operating system as, that definitely lets me know I have a problem. ngrap is a really good tool. So with ngrap, grep allows you to search for patterns inside of files. And anytime grep finds a match to the pattern you specified, it'll print out that whole line. ngrep is kind of the same thing, but for packets. So I can tell grep, I'm interested in this text string, and grep will check all the packets going by. And anytime it finds a packet that has that text string in it, it'll print out the results from that packet. So for example, here I'm saying ngrep dash lowercase q. Lowercase q says ngrep normally will print out a £sign every time it checks a packet and it doesn't find what it was looking for. Well, guess what? Most packets aren't going to have what you're looking for in it. So you end up with £signs that quickly scroll and fill up the entire screen. And then every now and then you might see something that you were interested in, zip right past on the top of the screen, too fast for you to read it. So dash Q just says, don't print out pound symbols. I don't want to see those. Dash capital I, read this file in, and I want to look for this string admin, and it is regex, so that is case sensitive. So, and then pipe it through head 15, which just means show me the first 15 lines of output. So ngrep says, okay, you told me to read this file and match on this string. And here's the first batch I found. This was a TCP packet coming from this IP, this port, going to that IP address, that port. The ACK and the push flag were set inside of the TCP header. And here's the payload. And notice in the payload, here's that admin string that I was looking for. This match here, this is a 404, meaning, hey, you asked me to go get something and I couldn't find it. And it always reflects back the URI you asked for. And here's that admin string here showing up. So again, if I need to go looking for a pattern inside of packets really quickly, this is a great tool for going through and doing that. And then we come to Rita. So we had Rita before we had AC Hunter. AC Hunter was kind of the commercial version of Rita, and now we have the community edition of AC Hunter, which kind of replaces Rita in a lot of ways, but we're actually going to continue to maintain both of them. Rita is a great tool if you want to script and automate a lot of your threat hunting because it works the command line. Community edition of AC Hunter is a better tool when you're going to be in and you're going to be doing it manually because it's graphical based. But Rita, like I said, command line. So it kind of prints everything out to the screen. One of the nice things about Rita is that when I go in and do my beacon analysis, it will give me a score. This is the likelihood of this being a persistent connection. So this one here, this is 100, we're 100% certain this is a persistent connection. Here, we're 83.8% certain that this is a persistent connection. Well, wait a minute, Chris. Why say 0.838? Why not just say 83.8%? Oh, because percent is a special symbol, and that will mess with a lot of people's scripts. So doing it this way just made it a whole lot easier to go through and do. But Beacon, Rita can also check for a lot of other things. It can look for beacons going through CDNs based on the SNI information that's inside of the HTTPS session. It can do the same thing with HTTP traffic using the host parameter. It can check for traffic going through proxies that are using the SOC protocol. It has a lot of stuff that it goes through and does. Pretty similar to AC Hunter. Yes, and the name of it is based on John Strand's mom. So John Strand's mom was named Rita. There's a great Darknet Diaries on his mom where she does a red team pen test against a penitentiary for John, which is just an awesome story and is just so indicative of what his mom was like when she was alive. She's since passed. A lot of reason why the tool's named after her, but she was definitely very cool people. So this brings us to AC Hunter Community Edition. So one of the nice things about AC Hunter Community Edition is that we prioritize the systems for you. So on the left-hand side here, this is telling me all my internal IP address ranked by score. The highest scoring systems are the ones that are most likely to be in a compromised state. So those are the ones I need to go in and pay attention to first. Those are the ones where I'm going to find my connection persistency that I need to look at and identify, is there a business need associated with it or not? So on the left, I identify a system and a score. Any system I click on the right, it's going to show you a breakdown of that score. So this first one, 94 points were assigned, and this was because there's a beacon generated off of that system. There's not much of a long connection running. The longest connection was only 2 minutes. There isn't anything else in here that's really all that interesting. So because there's a beacon there, that's something you may want to go in and pay attention to. The beacon screen, we looked at this a little bit earlier, right? This graph on the bottom, this to me, that's the money shot. That is the one that really helps me figure out, is this a persistent connection or not? When I can see this graphed out over time. I'm not a big, graph fan. I'm perfectly fine with data and numbers, but this is one of those cases where it just really kind of helps figure things out. Notice in this case here, we had 20,000 connections that took place from this source IP to that destination IP address. It was going to TCP 443, and you may not be able to see it, but the application is listed as dash, meaning I don't know what the application was on this port. Oh, that's a problem. That should be identified as SSL because TCP 443 is the well-known port for HTTPS, which uses SSL and TLS. And that doesn't seem to be what's happening here. The other thing that's kind of odd is these connections are going off pretty quickly, but there's kind of a trail here of longer durations taking place between the connections. That's kind of odd. Not sure what's going on with that one. But the beacon screen is kind of designed to help you very quickly figure out, do I have persistent persistency here to worry about? And then if so, help me to quickly go through and investigate this to figure out, is this something I need to be concerned about or not? And like I said, that graph on the bottom, that one to me is always where I start. That's what's going to help me figure out, is this actually persistent or not? The time interval count, our view one, like I mentioned, this is going through and breaking out how often was I seeing a particular dwell time. And anytime I see jitter, especially if it's got a bell curve to it, that tells me, yeah, this is probably going to be evil. This is something I need to go in and pay attention to. I did mention this one before, where this is the most random beacon connection I've ever seen. Someone actually put time and effort into it. Although AC Hunter still labeled this as like, we're 98% certain this is a persistent connection and you need to pay attention to it. Session 2 of view 2, this is an analysis of the session size. Now remember I said the largest peak you see, if this is a C2 session, that longest peak is going to be indicative of the heartbeat. That's going to be, do you have anything for me to do? No, go back to sleep. Any data sizes I see larger than that is going to be indicative of a data transfer. So you can see here, we're getting up into like the 1700, 1800 byte range. That may mean, yeah, we've got something here we need to worry about. There may be some data of value that's actually started leaving our environment. Now notice, normally we said the heartbeat is going to be the smallest session size. And in this case, it's not. We've got some other ones down here. But what is this? This is 40 bytes. What's 40 bytes? Well, if I look at the anatomy of my packet, my IP header is 20 bytes in size. My TCP header without any option set is 20 bytes in size. 20 plus 20, oh, hey, that's 40. So this is a SYN packet went by, but nothing happened. Maybe the receiving system was too busy and wouldn't accept the connection or whatever the case may be. But, if you see some noise down around 40, yeah, that's just failed connections. That's, the C2 server is probably too busy right now type of thing. This is the peak that's going to tell us a heartbeat. And now it's the delta between that heartbeat and the other sizes that's going to help me get a rough estimate of how much data has gotten moved out of my environment. Let's see, what data source is AC Hunter using? OwnDB, PCAP? Good question. So today it's using Mongo. However, that is in the process of changing. We've got some things we want to be able to do, some data we want to be able to parse that, quite honestly, Mongo isn't dealing with very well. Mongo's great for non-structured queries. For going in and, for coming up with, later deciding I want to be able to go in and look for this type of information, and it's not something I've actually built an index on, and, and it's great for that. But for this, we're getting into like the 50, 60 gigabit range for AC Hunter, and Mongo is our biggest limiting factor right now. So we're looking at actually replacing the backend database to be able to scale up above 50, 60 gig. Would you filter common or frequent sites from view? So it's not so much I would filter out common or frequent sites as I would look for that persistency. If someone's talking to a site persistently, yeah, I'm going to go in and I'm going to kind of dig into that. Now, let's say the site that's being accessed is, I can figure out it's the weather tile on a Windows 11 system. Yeah, all right. If I'm okay with that, if that doesn't break policy, create a safe list entry and never bother looking at that again. Would you? Yeah. So Elastic? No, we would not use Elastic. We blew up Elastic just when we were trying to scale to like 3 gigs, 5 gigs, somewhere in that range there. Elastic is not really designed to perform like that. I know it's a popular backend. It's got a lot of good uses to it. Heck, we're using it for Beaker, but Elastic just doesn't scale like some of the other databases that are out there. So target investigation, we looked at this, right? So under each IP, we're going to tell you as much about that as we can. What was the user trying to query when they got to that? Were the communications being used? If it's an external IP, what ASN is a part of? Who's responsible for that ASN? We're going to try and give you as much information on screen as possible to kind of figure out, is this something I need to be concerned about or not? Now, sometimes all the data doesn't fit. So here I'm doing a web analysis of a beacon, which means I'm using the application layer. So for HTTP sessions, I'm using the host field. For HTTPS, I'm using the SNI field. But I'm going in to see, hey, this beacon going to site.api.espn.com, I'll guess is the end of it. But notice the full name doesn't fit. Also notice for the HTTP servers, I see one IP address, a comma in the start of a second, along with some dots. Here I see some dots. Anytime we can't fit it on the screen, we just turn it into a mouse over. So this second shot here is just simply I put my mouse over it. And when I did, all these addresses pop up. So you can always get full resolution as to what's going on. We just might hide some of it on occasion if it doesn't quite fit on the real estate of the screen. Long connections, we talked about this. We actually looked at this one a little bit earlier. And I talked about how view one is total cumulative time. That's the one you want to be spending the most time paying attention to. But if I go to view two, I can look at unique individual connections as well. I can also go in and I can say, how do I want to sort this stuff? Right? I have a couple of different sort options. Duration, highest to lowest is typically the most common. But you'll notice that in most of these screens is I can usually go in and pick how I want to sort it. I can also usually go in and identify a threshold. So I can go in and I can say, only show me beacons that had a score over 50%. Or in this case here, only show me long connections that lasted 5 hours or longer. And I can make that number bigger or smaller depending upon what my needs are. I can also go in and do specific searches. So I can say, hey, only show me long connections associated with 192.168.1.50, or only show me long connections associated with 68.53.7.129, some external IP. I can just go in and tell it to go through and do that. In fact, we'll get into a walkthrough in a little bit, but let me just show you this real quick. So if I just click into long connections, or if I click into beacons, it's going to show me all my internal systems. It's going to show me everything, right? If I go into beacon web, same type of thing. It's going to show me all my different sources. It's going to show me everything ranked by score by default. I could change that ranking to connection count, dispersion, or whatever else I want to change it to, but it's going to show me everything. So when I click the icons on the bottom, I see everything about my environment that's associated with that particular module. If, however, I click here, right? So I'm looking at this first beacon, right? 192.168.88.2, it's saying there's a beacon, strong beacon score. If I click this, notice it automatically set up a search for that IP address. So it filters this as the only source IP address. So any results I see, even if I go over and I jump to long connections, it's only going to show me the long connections that are associated with this particular IP address of that set. So as you're navigating around, if it seems like you're not seeing everything, you may have gone in through here. And the thought process is, if I click over here, it's because I want to investigate this source. Therefore, I always want the source to be that system, even when I jump between modules. But if I go straight into a module down here, I'm investigating that type of connection. I want to see everything that's associated with that type of a connection. So threat intel is a little different, right? So threat intel is you can have lists of IP addresses or fully qualified domain names. And there's two files that you can append your information to that we will go through and we will look to see, does any of your traffic match any of those? And what I like about this is most intel feeds are crap. And I'm going to be blunt. I know I'm going to piss off a lot of threat intel folks, and that's fine. Most threat intel feeds are crap. And they're crap because when you look at what attackers are doing today, most of the time they're locating their resources in public space. It's in Amazon EC2, it's in Azure, it's someplace that's shared space. And they don't leave them up and running for that long. So one of the first challenges you run into with threat intel is if the IP address that you got is more than like 48 hours old, it's useless. If it's 6 months old, which a lot of these lists are still handing out IP addresses that did something bad 6 months ago or did something somebody thought was bad 6 months ago, that means nothing to you. The other challenge is you need to be sure what level are they vetting this information against. I see plenty of things end up in like virus total, like Microsoft constantly ends up in virus total. And people are labeling it as being port scanning and DNS spoofing and all this other stuff. And then you read their description and they're like, I don't know why I have traffic going there. Well, but you said it was a port scan, right? WTF do, So a lot of the stuff that ends up on threat intel lists are by people who maybe don't understand traffic as much as they should to be doing that job. And when it does end up on that list, it lives there too long. So what you end up with is a lot of false positives. So that IP address in EC2, 3 months ago was a C2 server. Today, it is Jane's Bird Shop running a web server that sells gear for watching birds. I just picked that one because, we've had woodpeckers eating out of our hummingbird feeders lately, and that's been kind of fun to watch. But, it's Jane's Bird Shop. But your threat intel list triggers on that IP, and you think it's working because you saw a match. Right? Oh, it matched and it kept that person from going to that evil site. This is doing good. Well, no, it's not. That IP address is just a benign website now. And unless you have a policy that says users can't go to like bird websites during working hours, then no, it's not doing its job. So we handle threat intel a little different. Here's what we do. You can put whatever you want on the list. And what we will do is we will assign a minimal number of points to that, 10. 10's enough to say, hey, just so you know, this happened, but don't freak out. Because then what we do is we start monitoring how many bytes of data leaves your environment and goes to this IP address, a fully qualified domain name that's on your threat intel list, because that's the key decider, right? So if I go to Mary's website or whatever I called it, right? I'm going to Mary's bird site. How much data will my system send to Mary's bird website? Not much, right? What information am I going to send? Let's take worst case, right? It's a TLS session. I'm going to send an SSL client hello. The server is going to send me information. And then I'm going to send a URI for data I want to request along with my user agent string and maybe a refer field. And that's about it. In other words, it's like, a couple of 10 bytes, maybe a couple 100 bytes. That's it. I'm not sending out much information. So what we do is if your internal system doesn't send more than 5 megabytes of data, 10 points is the only thing we assign to that session. If it exceeds 5 megabytes, we start adding in additional points. If it gets to 25 megabytes, we're adding in 100 points to make sure you pay attention to that system. What's nice about this is it's going to vet out your false positives, which my personal experience is that's usually 95% of what threat intel lists are these days. 95% of the triggers are actually just false positives. It's stuff you don't care about. It's stuff you're going to waste your time on. So now feed it in through our system. And if we only assign 10 points, don't worry about it. If you see more than 10 points get assigned, okay, now maybe it's worth your time. The cyber deception module. This one's actually kind of cool. So with the cyber deception module, show this one off real quick. Let's see, we don't need that. We don't need that. I can shut those. And we do have data on this here. Yeah. So the cyber deception module, what this allows you to do is set up little tripwires within your environment. So for example, I could go in and I could create a token, and the token is a user named John Doe that has administrative access, but it's not actually a real account that anyone's ever going to use. And what we'll do is we'll spit out a PowerShell script that you can then copy paste over onto your domain controller to create this user John Doe with a 32 character randomized password. So no one's going to brute force that anytime soon. And then it's going to go through and it's going to turn on full monitoring for that account. So now you might get an alert that says, hey, 192.168.88.2 just tried to log in as John Doe. Well, now you know, okay, I've got malware, I've got a rogue user, I've got someone logging into an account that no one should be using. That is a problem. I need to go in and pay attention to that. Maybe that internal system is now doing password spraying. So they're trying some simple passwords against every single account. They happen to hit the John Doe account. Or maybe they're focusing in on the admin accounts, and that's why they're hitting the John Doe account. In either case, yeah, it's something I need to pay attention to. You can also go in and create honey tokens for files. So I can go in and I can create what looks like an accounting login script on my net login share. And or I could create a token for that, and we'll create a script that will do that for you. And then since it's not assigned to anybody's profile, nobody should ever read that file. Well, from my red teaming days, when I got access to a Windows system, the first place I went was the net login share. The next thing I did, make a copy of all the login scripts. Why? Because that was a very low visible way for me to completely map out what the internal environment looks like without having to send out probe packets. If I start doing port scans or ping scans on your internal network, you might pick that up. All I do is make a copy of all your login scripts and then look through the login scripts to see what resources are located where. You're probably not going to detect that. Well, in this case here, I could create a canary token for that. The only thing that should ever touch this file is your backup system. And you can easily go in and say, oh, I want to create an IP exception for my backup system. And now anytime your backup system reads that file, we won't bother triggering an alert anymore. But any other IP address that touches that file, we're going to trigger an alert. I think a honey token is a decoy. Yes, it is. Absolutely. So a honey token is a decoy. It is a honey token, tripwire, use whatever lingo you want to go with. It's a fake resource that's there to look juicy and decent, so that someone that is in your environment will feel motivated to want to do something to it, which allows you to detect them a little bit easier. One of the other modules we have is Deep Dive. So what Deep Dive does is it allows you to get kind of full visibility on what's going on with a particular IP address. So let me give you an example. So if I go into Deep Dive and I say, I want to look at 192.168, notice it automatically looks through the data set to see what IP addresses start with that address range. And that way I don't have to type in the whole thing if I don't want to. But what this is showing me is out of all my internal systems, or excuse me, for this internal system, who did it talk to out on the internet? And it'll go through and it'll kind of break that out. So to break that out by first byte. So within the 173 byte, I talk to these two systems and we color code everything. So anything in white, that's our way of saying we didn't see anything suspicious here, right? This one here, one connection was made. So we're saying, we're coloring it in white because we're saying, yeah, we don't think there's anything here you need to be worried about. Anything in orange is our way of saying, hey, we saw something that looked a little off. It might be what generated all these threat points. It might not. It might even be something you've chosen to safe list in the past. We're going to show you everything here. But what this allows me to do is to kind of quickly get full visibility on what's going on with the system. What's really cool about this is I can very easily kind of pivot between systems. So for example, let's say I was looking at this and I was saying, I want to go in. I'm pretty certain this system's compromised. I'm pretty certain this is a command and control server. One of the things we talked about earlier is you want to get a handle on scope, right? Remember we talked about the dangers of isolating a system too quickly? So what if I want to figure out, is anybody else compromised? Well, all I got to do is click on that IP and select the deep dive option. This will show me everybody on the internal network that's talking to that IP address. If it's just this one system, I'm okay. If it's got 12 other IP addresses listed here, I'm going to want to investigate them as well. If I want to investigate this one a little bit further, I can click on it like I did there. That produces the summary over on the left-hand side. And see this little P button here? If I click that, I pivot to that being the IP address I'm analyzing. And now I can see everybody that system talked to out on the internet. over that same 24-hour period of time. So deep dive, pretty cool. The install process, fairly straightforward. So we make this available in a couple of different options. One is the VM for this class. And the only thing really unique about the VM for this class versus the other options is that it's got the lab files we're actually going to be using as part of this class. So if you don't have that, lab 1, lab 2, lab 3 directory that I was talking about earlier, it's going to be hard for you to do the labs if you're using some other install base besides pulling down the VM that's specifically part of this class. We also make a VM available with just the regular community edition on. So you can download that. You've got AC Hunter on a VM, bang, it's all ready to go. There's also an install option. So one of the nice things about the install option is if you run that, do you want to install AC Hunter? Yes, I do. Do you want to install Zeke? Oh, this will take care of installing Zeke for you if you want to. If you want to install Zeke, it doesn't have to be on the local system. You can tell this, I want to install Zeke at this other IP address. I want to install Beaker at this third IP address, and we'll just go out and do the installs for you. We'll ask you for creds, right? So one of the things we need is we need a login name that has sudo access to that system. But once you give us that, we'll reach out to that system and we'll automatically do the install for you. Kind of nice. So one of the nice things about, so moving on beyond AC Hunter, and I'll go back and we're going to do a hands-on walkthrough together on AC Hunter after we come back from break. But I want to get through the rest of these tools before we do hit break. So one of the other tools you could use is data mash. So data mash is actually a pretty damn useful tool. It's a statistical tool. So it's kind of designed for, hey, here's a range of numbers. I want to know what's the minimum value, the maximum value, the average value, the mean value. It'll go through and it'll do all that fun stuff for you. But one of the really cool things you can do with data mash is you can use it to add up columns. So for example, here I'm saying catcon.log. I'm using zcut to pull out the source, destination, IP address, and the duration of the connection. And then I'm saying sort it, cat-k3 means on the third column. -rn says reverse sort numerically, meaning I want to see longest connections first. And then head 5, just print out 5 lines. Well, notice when I do that, look at these 2 connections here. It's the same source, same destination. So it's 2 separate connections between these 2 systems. Well, what if I want to add those numbers up? I use data mash for that. I'll talk about this in a second. So here I'm telling data mash, hey, when column 1 and column 2 are the same, meaning when the source IP address and the destination IP address are the same, add up the value in column 3. So notice that's what happened here. Instead of about 42 seconds and about 31 seconds, you just added those 2 numbers together to come up with 73. So this will do math on a column for me if I need to. That's kind of awesome. Now, what do these grep commands do? Data mash only works with numbers. So if I feed it anything that's not a number, it's going to puke on that and stop processing. So for example, this grep command removes blank lines from the output. Because again, if data mash sees a blank line, there's no number there for it to work with. It doesn't know what to do, and it just pukes and dies. So this gets rid of all my blank lines. Remember, the duration sometimes is a dash value. If Zeke sees that someone tried to connect to a port, but the handshake didn't actually complete, it labels that as a dash. It labels that as, hey, you tried to connect, but it couldn't fully connect, which means it's not even like a 0 duration session, right? The other side didn't even want to talk to it. It immediately ghosted it. So it'll label that with a dash. Well, again, a dash is not a numerical value. So this grep command just removes all of those lines from those output. So this just cleans the data up a bit in order to be able to feed it into data mash, so data mash can go in and add up those third columns. Beacon Threat Simulator. This is a cool tool. So this is another Bill tool. Notice the pattern here. See, Bill's official title within our organization is Master of Shitty Little Shell Scripts. There's a reason for that. He's really good at writing this stuff up. So what Beacon Simulator is good for is Imagine you want to test your current capability to detect beacons, right? You want to do a simulation of an internal system that's been compromised, and it's going to call out to an EC2 or an Azure VM you're running, or whatever the case may be, right? You're going to have it go out to some IP address out on the internet, and you want to see, okay, can the security ops team detect this is happening and identify this as something that needs to be paid attention to? Beacon Simulator is a real simple way to go through and do that, because I simply go in and tell Beacon Simulator, here's where I want you to send the traffic. Here's the port I want to send it to. Here's my timing information. Actually, here's the port I want to send it to. No, this is the size. I'm sorry. So port, here's my timing information. I want it to be a TCP packet, and I want to vary the session size from 0 to 5,000 bytes. That last option's kind of cool, because we're not seeing attackers do that yet, but we probably will. They've been jittering timing for a number of years now. When we start detecting their C2 too often, I can guarantee they're going to start jittering their session size to try and fly under the radar that way. So it'll behoove you to know, do you have the capability to detect that once that starts going live? This allows you to go through and simulate that. You can also do this with just some simple scripting. So here I've created a very simple script called Beacon Test. And Beacon Test basically says, keep doing this over and over again until I kill this process. And what it's telling it to do is run the curl command, set the user agent string to Mozilla version 0.0001 running on an Atari 7800. You've probably heard me mention, running IP on an Atari 7800 earlier. And some of the younger folks might have thought, oh, did Atari 7800s, run IP? No, they did not. There was no web server cartridge or anything like that. So, you're never going to run into this in the wild. But I like to use this just because Atari 7800 is a pretty unique pattern to match on. If I want to go try and see, did something log this properly? It'll allow you to go through and find it. And Bill's sharing his business card. Awesome. Yep, that is his official title. So what the script is doing is it's saying, use that as a user agent string. I would feed as a variable the IP address I want to send it to. So I would say beacon test space, 1.2.3.4, whatever that external IP address is. This says, hey, don't print anything to the screen. This is going to be a script running in the background. And then I'm running a sleep command that says sleep for this number of seconds. And the number of seconds is determined by this tool, Shuff. Shuff is simply being told, pick a random number between 200 and 350. Dash N1 means pick only a single value. So what this is going to do is it's going to pick a random number between 200 and 350 and feed that to sleep. And that's the number of seconds sleep will sleep for. So if I want to jitter how often this is beaconing out, I can go through and I can do that. So you can even kind of hack this stuff together yourself. These scripts can be super useful. Here's one that I kind of walk folks through in my advanced class. So when you run the FQ command, it'll go through and you can hand it an IP address, or you can hand it a fully qualified domain name, and it'll check all of the Zeke logs in the local directory to see what is known about that. So for example, here I'm running FQ against a specific IP address, and it's coming back and saying, oh, hey, that IP address was the answer when somebody did a search for fw.adsafeprotect.com. There was no HTTP traffic associated with that IP address. There was a TLS session. Here was the SNI information in that TLS session, and the digital certificate was considered valid. So it's just a quick way to be able to go in and say, hey, Zeke, tell me what you know about this IP address. Blah, here you go. Writing scripts like that to automate a lot of the simple common tasks you do is a great way to go through and do your hunting. And coming soon, Bill Stearns will be doing a class on doing this stuff. I don't think it's on demand just yet, but I think they're getting ready to launch this really soon now. So I would expect to see this out over like the next month or two.
Just going through the last parts of the review right now.
Perfect, dude. So yeah, that'll be I believe, Bill, is that going to be a pay what you can class?
That's in negotiation. I'm trying to make it inexpensive, but I can't guarantee that at the moment.
Okay, cool. Cool.
There was a question about whether there would be enough time for somebody to do a longer break, taking a dog for a walk at noon or 2 o'clock. Is that part of this upcoming break?
Yes. Yes. So yeah,
Great.
let's segue into that. So we are going to go into a 20-minute break. It is 5 minutes after the top of the hour. I ran a little late. I apologize for that. So let's say 25 minutes after the top of the hour, we will pick up from here and keep going. So I will catch you all then. Hey, and we're back. So Josh had a question. If you were an MSP and you were using this for clients, how would you go about setting this up? Great question, Josh. So it really kind of depends upon what makes the most sense for your organization. You suggest one possibility where you set up an instance for each client, and you could certainly do that. The commercial, the community edition, obviously it's free to use, so you can set up as many copies as you want. The commercial edition is the same way, meaning it's an open site license in that you could run as many copies as you want at no additional cost. There is a fee around managing security for other people. It's pretty small. We could talk about that offline. I don't want to kind of get into it during a training class, but that is one possibility. You could pull multiple sites together into the same AC Hunter instance. The challenge you run into there is what if they have overlapping IP address space? That could make running down, did this happen on client A versus client B a little bit more challenging? One of the nice things is you can run AC Hunter in a VM, as we're seeing. We're using that in this class. So you don't have to dedicate a whole lot of resources to it if you do end up running a VM for each of your customers. So that's just a couple possibilities right off the top. All right. So we're going to get into doing some labs. And before we do that, I want to do a walkthrough. So with a guided walkthrough, I kind of want you to go along with me on this. In other words, I'm going to go through and I'm going to do a couple of things within AC Hunter. And as I do that, I kind of want you to follow along with me as I do, just to make sure that, you're kind of familiar with the interface and you can kind of find your way around and all of that fun stuff. Then we'll get into doing labs. What I do with the labs is I'll state a problem. Hey, here's something you need to go through and do. Like check this data set to see, is there any persistency here that we should probably look at, more closely? So I'll give you some sort of a problem to go after. What I will always do is after the slide that identifies what you should try and accomplish in the lab, the next slide will always be a hint slide. So let's say, I've been doing this for a while. It's just the tool's a little new to me. And I read that and say, go and hunt this data set. And I look at that and I say, oh, yeah, okay, I can figure that out. I'll just use the lab slide and bang, go off from there. Let's say I'm a little bit newer at this. And I'll say, okay, I know what you mean when you say hunt for persistence sessions, Chris. I'm not really sure how to even get started with that. That's okay. Go take a look at the hint slide. The hint slide isn't going to give you the answer, but it's going to kind of help point you in the right direction, right? So the hint slide will tell you, you kind of want to go more north than anything else. It'll kind of help guide you as to, what you should go through and do. If you read the hints and you're still not sure, after that, I've listed the answers. If you're brand new at this, don't feel bad about going straight to the answers and going at it from there. And I will kind of walk through these as we go. And just as a reminder, to log in via SSH or to log in on the console, the login name is threat, the password is hunting. Pretty easy to remember. When you log into the AC Hunter interface, however, the login name is threat at activecountermeasures.com. And the password is hunting2. It needed to be a little bit longer than just hunting. It needed a little more complexity to pass this password for the user interface. The VM access, I talked about this, and we covered this back at the beginning of the class, where if you're using VMware, you can connect up directly to whatever IP address gets assigned to that VM, but that might change. And I gave you a command to go through and figure out what IP address was assigned to your VM. If you're using VirtualBox, you need to go through and set up port mapping. I also kind of talked you through that. I think I have a couple of summary slides here. Yeah, I have a couple of summary slides. but I have a blog post that walks you through the whole thing. Once you do, once you get that going, now you can remote into the box. If you can't get any of that going, that's okay. Just work with inside the VM. There's a, let me show it to you real quick. So here's my VM console. I'm going to type in hunting for my password. Once I do, here's my terminal. So if I click that, that gets me into the command line. If I look at where I am right now, I am in my home directory. There's a labs directory, so I can CD into labs. If I look at what's there, lab 1, lab 2, lab 3. We're going to start with lab 1. And then there's all my Zeke files. So I can use the terminal from here if I want to. I can also run Chrome and just point at the local, point at 127.0.0.1 to connect up to AC Hunter. So if I click that, this may take a second to run, but as you can see, I can work inside of the VM as well. So working remotely via SSH is optional. And I don't want to update Chrome right now. And I want to click on Advanced, Proceed. And if it's your first time logging in, it'll hit you up for credentials. Again, threaded active countermeasures, passwords hunting 2. And then you'll be able to get in and get to the console this way. Notice everything looks a little odd. It's because I've got the screen so small. So if I go up here and if I go to full screen, that'll fix it. That'll make everything lay out. I can also go into Chrome and I can use the zoom keys to try and zoom in, zoom out, and try and get this to look a little bit cleaner that way too. So that's two of my possibilities if I'm working inside of the VM itself. So I gave you all the little links depending upon what platform you're running, depending upon which one you want to use. And yeah, like I said, we're going to start right off with using the DNS Cat2 JA3 strobe dataset. If you're using the class VM, this is what you'll see. You'll see this dataset, which is the one we're going to work with. So you want to highlight it and then click the confirm button down the bottom. There's also a dataset in here called proxy. That one is just there so you can see how the tool processes proxy data. In other words, all of our data is not going directly out to the internet. Our data is actually going to, go through a proxy, and then that proxy will go out to the internet. How do we go through and process that? I wanted to go through and give you slides for that. And actually, let me launch the console and we'll use this. So here is the main screen. Anytime I want to get back here, this dashboard button on the bottom left, this will always pull me back here. This is all of my internal systems ranked by score. Highest score means there's more persistency going on there. I want to go in and pay attention to them first. Over on the right, it's going to give me a breakdown of where are those score points coming from. Now, if I want to change my database, right? Let's say I wanted to go look at that proxy database. Go up here to the right, click the little gear icon. It only shows up on the dashboard. So if I go to like the beacon screen, there's no gear icon. Threat intel, there's no gear icon. I got to be on the dashboard. That'll get me my little gear icon. I click that. By default, it opens up my data sets. I just pick the data set I want to load, hit confirm, and it'll go through and it'll load that up for me. I want to switch back to where I was, back to my data sets, DNS Cat2, JA3, hit confirm, and it'll go through and it'll load that up for me. So pretty easy to go through and kind of navigate through things. Now, let's say I need to add a safe list. Let's say there's something I'm looking at that I decide, this isn't so, this is something that there's a business need associated with it. Let's see if we can't find a good example. So I'm going to go to the Beacon. So like I said, follow along with me here. So I'm going to go to Beacon's Web, right? This is that third icon, and I'm going to click that. And when I do, let's try this one. Yeah, this is a good one. So my internal system, 1055.182.100, right? This IP address here is connecting to config.edge.skype.com. There's only one IP address we're talking to. The subject, meaning, what's the SNI information for the digital certificate associated with this session, is the same as the fully qualified domain name that was hit, edge.skype.com. So that's good. Actually, yeah, so it's going to be a wild card. Invalid certificate. Is this certificate okay? Invalid certificate. No, it is not an invalid certificate. Why is it worded that way? That sounds kind of weird, just because it's easier to go in and kind of program it like this. So if it's no, that means it's not an invalid certificate, which means it's okay. Then yeah, this is legit cert. So let's say we look at this and we say, yeah, this is something that we use Skype internally. So this is perfectly legitimate. I'm okay with this type of traffic going by on my network. This is not something I want to see anymore as part of a threat hunt. See this little icon up here that looks like a filter? That's my safe listing capability. So next to every IP and fully qualified domain name, I'm going to get a little filter. So what I want to do is I want to click on that. And when I click on it, my safe list screen appears like I see here. And it gives me some options for going in and creating a safe list. I could choose to do it based on the source IP. I don't want to. I can do IP pairs if that's an option. But in this case here, we're doing it based on the fully qualified domain name. So it kind of defaults to wanting to set it up that way. So I want a safe list based on the fully qualified domain name for all internal hosts, meaning not just this one system. If any of my internal systems want to go to config.edge.skype.com, that's okay. I don't want to see that show up in any of my hunts going forward from now. So now what I'm going to do is I'm going to say, okay, what do I want the A record to resolve to? Well, it's going to automatically default to whatever the name of this host is as part of what I'm creating the safe list entry for. I can choose to create a wildcard or not. In other words, if I just click safe list, it's only going to safe list config.edge.skype.com. Now, what if I want to make that a little bit more general? I can enable wildcards for that. And then I can take my little slidey bar and put it here. And now what that's saying is anything.edge.skype.com is okay. In other words, don't score it, don't show it on the screen. And then I could write in a comment as to why I went in and created a safe list entry. So if I track things through Jitter tickets, this could reference a Jitter ticket. At the very least, this should have an explanation of why the safe list entry was created. Normal Skype traffic or whatever the case may be. And I probably want to put a date stamp in there so I know when it was created. And I might want to put my name in there, C. Brenton, so that someone can come back to me and say, hey, you were the one who created the safe list entry. I have this question about it, or whatever the case may be. Once I tell it I want to apply the safe list, if you watch what happens in the background, the data gets updated. And notice that entry is now gone. Right? That's no longer my second entry. OneNote is my next entry. Oh, OneNote, I know what that is. I could safe list entry that as well. Yeah. Like I said, your first couple of hunts, you're going to go in and you're going to safe list stuff. But after you've done that, and it takes about 3 or 4 hunts to get a majority of what's on your network, once you've done that, anything new that pops up, that's stuff that's worth going in and paying attention to. But that's what my safe list entry does for me. Now, let's say, what does that safe list entry do? All that safe list entry does is it hides the data. It doesn't actually delete anything. So let's say a week from now, I realize, oh, shoot, that wasn't what I thought it was. I thought that was a legitimate Skype site, and it's actually not. I need to get rid of that. What do? I click on it. I click on the gear icon. I click on this line here that says safe list. And notice I've got one safe list now. That's the one I just created. I can click view edit to see them all. And there's the safe list entry I just created. If I want to get rid of it, I click the little X. That removes it. And now all my safe list entries are gone. Now that'll show back up again as my second entry. Well, what if I deleted it a week ago, Chris? Well, we still collected that data. We just didn't score it and we didn't show it to you. So if you need to go back through, if you need to remove the safe list entry and go back through it, You can do that, and you're still going to be able to go in and kind of see everything from there. Now, the other way to get into things is to go in through the right-hand side, like I talked about. So so that time I went straight to the Beacon web module. This time, what I'm going to do is I'm going to say, oh, this has a beacon score. So I'm going to click on that. That sets up a filter so that I'm only looking at that source IP address. So which way you go in kind of depends on how you want to go investigate things. Now, let's say I'm looking at this and I'm saying, okay, this is, what is this? 99.9% persistency. That's scoring pretty high. We don't know a lot about the destination ASN. It's UDP 123. So this looks like it might be NTP type stuff. But how do I find out more? Well, anytime you see an IP address or a fully qualified domain name, notice my pointer changes to a little pointy hand. That tells me there's a pop-up menu there. So I can click on that, and that'll give me my pop-up investigation menu. So I could go into deep dive like we did before, or I could say, hey, virus total, tell me what you know about that IP address. And now this will go to virus total. It'll feed in that IP address automatically for me. And now virus total is telling me 0 of the 87 tools that we use to check for malware didn't notice anything associated with the site that's considered a problem. Here's what a virus total mapped that to over that period of time. So in other words, that IP address, what was it associated with? Well, back in May 19th, so just a couple of days ago, it was associated with NS4VICU. Okay, that's kind of weird. Back in March, it was associated with pool.ntp.org. And you see pool.ntp.org a lot. There's some weird names in here. I'm not sure why those are showing up, but I can see pretty consistent here. This is UDP 123 traffic, which is associated with NTP, going to what is frequently identified as an NTP server, although sometimes it's associated with other stuff as well. Let's see. We did have one scan that found some things thought was interesting. So you get the idea. I have all sorts of information I can go through and review here. And if I don't get everything I need off of virus total, hey, I can go to abuse IPDB and see what it finds. This IP was reported one time, confidence of abuse 0. I like this because they actually look at their data results to see, is the results that are here something that's actually worth going in and paying attention to? Cool. Let's go look at long connections. So if I click on long connections, similar to what I saw on the other screen, source IP, destination IP, here's some summary information. Again, anytime the full information isn't showing, I can just mouse over and it'll show that to me. This is total cumulative time when I'm in view 1. If I go to view 2, that's my individual sessions. But for long connections, I like to look at anything that's lasting 5.5 hours or more. So you want to be able to catch C2 channels that only operate during, quote unquote business hours, but you don't want to go so low that you're going to get a lot of false positives. You're going to get a lot of stuff you don't want to deal with. 5.5 hours seems to be the breaker bar for me. So 5.5 hours or more, I'll go through and I'll check that out. Anything shorter than that, I'm not going to bother paying attention to. And again, I can go in. So I'm just going to pick one at random here. The 65, 52, 108, 195. If I click that, here's my investigation menu. Hey, virus total. What do you know about that IP? Oh, that's associated with Windows.com and MSN. Oh, okay. That's probably something I'm not going to be worried about. So now I can go over here and I can click my filter icon and I can say, hey, anytime this IP address talks to that IP address, safe listed. If I want to make this a little bit more general, I can go to destination and I can say anybody on my internal network talking to that destination IP address, don't worry about it. I wouldn't do this yet. I haven't investigated it quite enough, but we looked at it quick off the top. It kind of looked like, yeah, this is maybe just normal Microsoft traffic. We might not have to worry about this. So I'm assuming we did the investigation to confirm that, in which case I might want to create a safe list entry. Here's the steps we'd go through to kind of do that. So that's kind of a walkthrough of using the user interface by default. Let me do a quick check here. See, do we have any questions? How many entries can we safe list? The community edition does 50. The commercial edition, it's unlimited. So you definitely, with community edition, want to make use of those wildcards where you can. Let's see. Can this tap live port mirroring? So as Bill explained, Zeke is what actually goes through and collects the traffic. Then AC Hunter processes that information. And in fact, we're going to get into doing that in just a second. So if Web Labs can't use safe list entries, what are we to do? Not sure what you mean if Web Labs can't use safe list entries. I'm not quite sure what you mean by that, dude. If you could give me a little bit of a deeper explanation, I might be able to give you a good answer for that. But normally you can create some sort of safe list entry around whatever it is that you're looking at. The T-Hunt AI. I'm not sure what I'm sorry, Jay Brown. I'm not sure what the T-Hunt AI is. Sorry, I apologize for being dense on you, dude. All right, so here's what we're going to do next. So now we've kind of had a walkthrough of the user interface. Let's look at how to get some data in there. So there's a couple of possibilities. One is Zeke can collect this data. Zeke can go through and write out log files once per hour, and then AC Hunter can go through and read those logs. But since we're running these on VMs on our local system, it's a little hard to get something useful that way, right? You're not going to see much data on your local VM network. So what we're going to do instead is we're going to use Zeke logs that have already been created. So I am in the home directory for the user threat. And then I went to labs here. I'll back all the way up. So launch a terminal session like you see me have here. And then I'm going to go to labs, and then I'm going to go to lab 1, just like that. And when I do, I'm going to see some Zeke logs in there. Yay, Zeke logs. So here's what we want to do. We want to import those logs into AC Hunter. And the tool to do that is Rita. Rita is actually running in the background behind AC Hunter. We made that decision early on to make sure that we didn't add a feature to AC Hunter and then not get around to adding it into the open community edition. You see that a lot where, capabilities don't match between the open source and the commercial tools, and we wanted to try to avoid that. So AC Hunter actually just uses Rita on the back end, and that makes it a lot easier for us to make sure that both tools are always up to date. So Rita is what we use to actually import data sets. So I'm going to use the keyword Rita, and then I'm going to say I want to import, and then I got to tell it what I want to import. Well, I want to import these log files. So I'm going to say import star.log. Since I'm in the same directory as these log files, I can just say star.log. Otherwise, I might have to give it an absolute path to where the log files are located. But since they're in this directory, I don't have to worry about that. Now I'm going to go through and I'm going to say, now I have to tell it, when you import it into AC Hunter, what do you want to name this data set? Well, we're importing it out of the lab 1 directory, so I'm just going to label it lab 1. Once you got that, you can just go ahead and hit enter. Now it's asking you for the password. The password is hunting, all lowercase characters. Once you do that, let me go through this output just a little bit once it finishes. So for anybody who's used Rita before, you might have seen this. It prompted us for a password, and then it said creating AC Hunter API run done. Say, wait a minute, I've used Rita before. It's never done that before. Why is it doing it now? This only happens because Rita is on the back end of AC Hunter. If you run Rita by itself, you won't see that. That's just part of it going in and talking to the right enclosure that's running it. But you can see here it parsed out the different log files. It imported them. This gives us some summary information about what was imported. And now if I say Rita space list, that'll give me a list of all my databases. Here is DNS Cat 2, the one we were looking at before in the AC Hunter interface. There's that proxy one I talked about. Local rolling, which I didn't talk about yet, but I should, and I will. And then here's lab 1, the one we just imported. If I close this up and go back to my AC Hunter interface, click on the gear icon, go to my databases. Hey, look, I have a lab one directory. I have a lab one data set now. Now I can go in and I can do a hunt on that lab one data set. Now, before we do, I want to talk about localhost rolling. Localhost rolling, if I have Zeke monitoring the network live, and Zeke is taking log files once per hour and feeding it into AC Hunter, all that data ends up into this rolling data set. So dash rolling means this is the most current 24-hour piece snapshot of what's on your network. So if I was hunting on my network with live data being collected by Zeke, that would be the data set that I go through and use. If I'm not normally running Zeke, if I'm running PCAPs, would have to run Zeke against the PCAPs, convert it into Zeke logs, and then import it in the way we just went through and did there. All righty. So I'm going to load up lab one. Let me see if I missed anything here. Let's see. So guided tour. Yep, I talked about zooming in, zooming out. I talked about how to pick different databases. We created a safe list entry together. Oh, and this is actually the same one I picked. Awesome. That's cool. We talked about, yeah, this looks like Skype. It looks like it's okay. So we're going to create a safe list entry on that by clicking the little filter icon. We talked about wildcarding. Once we did, that removes that entry. What else? Yeah, if we want to manage our safe list, like delete the one entry that's here, I can go in and I can say safe list, view edit. Here's the one entry for Skype that I created before. Like I said, you may want to identify who created the safe list entry and when they did it, just so you've got some little bit of an audit trail here. If you're using Jitter tickets to drive changes within your environment, you would identify the appropriate Jitter ticket for this. Let's see what else we got. Yeah, I talked about this. I talked about when you access the module on the bottom, it's going to go through and identify that if you, or it'll show you everything. If you select things off of the right-hand side, it's going to focus in on just that one system. We talked about the investigation menus. I talked about deep dive earlier. So we've already gone in and I talked about pivot allows you to switch between the two IP addresses currently being analyzed. What else? Yeah, virus total. I talked about that. Sometimes the findings are a little sketchy. I talked about that. Long connections. We looked at that. Data import. We just went through and did that together. So you've got slides documenting all these steps for you. And then here was our data import. Once we did, that shows up in AC Hunter. And hey, we're ready to go in and do our lab. So here's what I want you to do. So this is our lab. Go to the Beacon web module. So in the AC Hunter user interface, go here, click the Beacon web module. You should see this. 6 entries are scoring above 80. What I mean by that is if I look at how certain are we of the persistence, the 6 entries, 1, 2, 3, 4, 5, 6, 7. Oh, the 6. Yep. These 6 score 80 and above. Typically, anything scoring above an 80 is worth taking a look at. This one scores 70. So we're going to skip that. Now, if it was me, live environment, I'd go through my 80s only. Once all my 80s are gone, now I might go in and take a look at some of my 70s. I'd never go below 50. I wouldn't bother, regardless. But these top ones that are color coded as red and orange, I want you to go in and I want you to do a deep dive on those. So spend about 60 seconds max on each. Do any of these look suspicious? Do any of them look like they should be safe listed? So when you list them off, notice every time I select an entry here, the destination IP address changes. So for this address, does this look suspicious or not? For this destination, does it look suspicious or not? What about this one? What about this one? And so on down. So I want you to take a run through those. Don't go way down the rabbit hole on this. Do a peripheral check with the information that's on this interface, or if you open up, one of the third party sites and investigate that. Go in and check that out. and we'll talk more about this later, but I just want you to look at those 6 and identify which ones do you think are probably going to be okay, and which ones do we probably need to spend some more time investigating. I'm going to go on mute, but let's see. Did you create your own AC Hunter instance on Kali? No, we don't. It's just we use Ubuntu, and we just create it ourselves. So I'm only seeing 4 in the Beacon Web module, Mantic. Okay, Mantic, what I want you to do is go to the gear icon up here, go to safe lists, make sure you don't have any safe lists. If you do, click delete all. That'll remove your safe list entries. Now, once you do that, go back to Beacon Web. You should have 7 entries listed here. I see 2, not the 6. Same thing. Go to safe lists. You probably get some safe list entries filtering some stuff out. Get rid of that, and you'll be in much better shape. If you're on the shared instances running on the web, someone may have created a safe list entry for you already because it is a shared instance. So we're going to hopefully fix that for the next time we run this class in August. Well, I'll talk about that later. All right. I'm going to give you some time to go through and do this lab, and then we will go through together and we will talk about it. Now that you've had a chance to kind of take a quick look, we're not done yet. I'm going to give you more time. But what I did want to say is that one of the things I like to do from a threat hunting standpoint is go after the low-hanging fruit first. In other words, if I spend a minute or 2 and I'm not sure, make a note, put that one aside, go to the next one. Why? Because it's real easy to go down a rabbit hole on one and spend hours on it, and now nothing gets done. If you can look at it, and for the ones that are legitimate, you can usually within about 60 seconds figure out, yeah, this one's probably okay. That kind of checks that off as off your list and out of the way at that point. Excuse me. So if you spent about a minute looking at it and you're saying, Chris, I'm not sure if I need to worry about this or not, that's okay. Make a note of that one, put it aside, go to the next one. If that one takes you more than a minute, go to the next one after that. Hopefully that, the third one is, oh yeah, okay, I can kind of tell what's going on here. Great. There's one solved. Now you've still got a couple more to go, and then we can go back and hit the harder ones again. So I'm going to give you a couple more minutes working on this. Yeah, if you post anything in the channel that could be an answer, please go through and use the vertical pipes as Bill's talking about. That way it goes through and hides your answer, so people don't accidentally see it, before they've had a chance to go through and do the labs themselves. It's courtesy to the other students in the class type of thing. Tell you what I'm going to do. It is 3 minutes till the top of the hour. We're not going to cover this effectively in 3 minutes. So what I'm going to do is I'm going to say we will not cover this answer until after our next break, which will end at 10 minutes after the top of the hour. So if you're done and you want to go water the dog or, spade the cat or whatever you need to do, go hit that up. I won't cover anything interesting until 10 minutes after the top of the hour. If you need a couple more minutes to work through this, hey, go ahead and take it. I want, because it's the first time we're really going hands-on, I like to give people a little extra time to work through it if they need it. So feel free to kind of, go into the break, play around type of thing. And like I said, 10 minutes after the top of the hour, that's when I'll jump back in and we'll actually cover this first lab. All right. See, got a couple questions in here. Let me flag those. A little off topic, but I know everybody isn't just sitting hungry from 11 to 5, which you're all eating on during class. So I do not touch food when I'm eating. I had a horrible, horrible experience teaching down in Australia one time where I got food poisoning. And the worst part was I was the only one there who could teach that content. So I still had to go on. So I basically taught for 20 minutes, spent 20 minutes in the bathroom, taught for 20 minutes, spent 20 minutes in the bathroom. It was a horrible, horrible day. What made it even worse was eventually people started coming in and saying, hey, so I know you're not feeling good, but while you're in that bathroom stall, can I just ask you a question real quick? So yeah, no, that's not fun. So yeah, I don't touch food while I'm teaching, but I'm sure other people do. I saw something about like everything bagels. So, go for it. Let's see what else. Does AC Hunter add any additional features aside from what Rita does other than data visualization. So I think the biggest thing, Pause, is that you can set up alerting. So you can go in and you can say, hey, if any of my systems increase in score 10 points or more, 15 points or more, whatever you want to set it to, send an alert to my SIM. So now you don't have to watch the screen. You don't have to go in and really do hunting unless you get a notification identifying, hey, there's been a persistency change on one of your systems. And in the alert, you'll get a little link. You click that. That'll bring you into the AC Hunter system, and you can kind of go check it out from there. So most of the differences between the community edition and the enterprise edition are community is great for like small network, home network, that type of thing. If you want to like operationalize this within like a SOC, that's where the enterprise version really shines, features like that. What else we got? The very busy Discord server. Yes, it is. Oh yeah, there was another question back here. I would love to know if I can download the import file into my Kali VM that has all my other stuff on it. Yeah, and there was also a question around like, how do we operationalize this when we get back to the office? So here's the thing. So this VM is kind of for like training. I've kind of geared it for this class. You could go in and set up a Zeke system and copy logs over and all that stuff, but it'd be kind of a pain. Your best bet is to probably go to the Active Countermeasures website. Here, let me find it for you. Yeah, go to Community Edition, scroll down a little bit. Here's that comparison chart that Bill was talking about. So these are the differences between the two. But you get a couple of different download options. You can download this as a VM that Bill's gone through and created. So this is it's just a VM you can download and has everything running on it for you. Or you can download the install script. The install script gives you a little bit more flexibility because when you run, so let's say that setup where, hey, I've got everything running on Kali and you want to run this on Kali. Hey, you can certainly do that if you want to. I haven't tested it. I'm not going to guarantee it's going to work. I don't know if the Mongo database is going to conflict with another database you might have on there, but hey, it's certainly worth trying to give a whirl. So what you would do is you would run the install script, and the first thing it would ask you is, do you want to install AC Hunter? And you tell it, yes, I do. And where do you want to put it? I want to put it at 127.0.0.1, the local system, or I want to put it on a different VM. You could point at an external IP address, and if you do that, it'll ask for credentials. Then it'll ask you, where do you want to install Zeke? Zeke, you really don't want to run on a VM. VMs are horrible, horrible, horrible at capturing packets. The little bit of testing I've done is once you hit about 100 megabit, you've tapped it out totally. And that's assuming you're running an internal infrastructure as a service environment with a network, high performance network card dedicated to just the VM trying to do the capturing. Even after all that, you're going to max out at about 100 megabit. Better option would be like a Raspberry Pi or equivalent. That's going to easily get you up to like a gig. But you can, as part of the install script, it's going to ask you, do you want to install Zeke? You can tell it yes. And then you give it the IP address of where you want to install Zeke. What the install script then does in the background is it says, okay, so Zeke is here, Zeke is off to the left, AC Hunter is off to the right. Those two systems need to talk to each other. So I'm going to create an account called data import user on the AC Hunter system. And Zeke every hour is going to run a process where it takes its log files, compresses them up, transfers them to AC Hunter using SSH with public private keys. And then it'll take those log files apart on the AC Hunter side and automatically import them for you. And it'll create it as part of that running data set. So that would be my suggested way if you wanted to do this in like a production-y type of environment. But, certainly we've given you lots of options in case you need something we haven't thought of. Let's see what else. If users are connected out to a VPN, would Zeke be able to see the individual connections? Would all connections just show the VPN server? So yes, if you, let's say you have a VPN in your perimeter and users are connecting to that VPN, then yeah, it's just going to show everybody connecting to that VPN, and that's it. Usually what happens though is it's done at a routing level, right? Users don't connect to the VPN and then jump out from there. It doesn't act as a jump box, it acts as a router. So typically what will happen on the network side is they'll say, hey, anything going to 10 dot anything, send it down the VPN. And now when the user tries to get to any 10 address, that's just routed down the VPN. With Zeke would still be able to see what specific IP address they were actually trying to go to once they got to the other side of that VPN. So it depends on the setup. If it's your normal like site-to-site VPN, yeah, you can see what people are trying to go to on the other side, so long as you're looking at it before it gets wrapped inside of that VPN tunnel. If they're connecting to that box and then jumping out from that box, yeah, you're going to see people going to the box and that's it. But the first option is the most common. All right. So let's kind of talk about this one a little bit. Let's go through some of our options here to kind of see. All right. So we had 6 of them we needed to go through, the 7 here total. We said the last one, we can skip that. The score is low enough. Weren't going to bother paying attention to that. We're going to pay attention to the first 6. So is there anything in the first 6 that's actually interesting enough to make it worth going in and kind of paying attention to? Well, let's start with the first one. So I've got my internal system. It's going to an IP address out on the internet. Okay, this is my first auditing right here. HTTP server that it was going to, and it has an IP address listed. It's pulling that information from the host parameter in the HTTP traffic. That should be a fully qualified domain name. So the concept is, imagine I have a web server running that has 50 different virtual servers on it, right? www.fuba.org, www.bof.com, they're all running on this same box. Well, all of those websites are using the same IP address. So how do we figure out which one of those virtual web servers you were actually trying to talk to? And the answer is the host parameter. That needs to be a fully qualified domain name to get to the right virtual server. And here it's not, it's an IP address. That's odd. The only time I've seen that is like vulnerability scanners and bad stuff like that. So that's immediately raising a red flag for me. So this was a GET request to port 80 on that system. Look at this. So the user agent string is Mozilla 4 Windows 7. Well, all right, maybe we still have Windows 7 running on our network, but probably not. This is where something like Passor or Smudge would come in handy. Do we have a passive fingerprint of that system? Does it fingerprint as Windows 7? If it does, well, okay, yeah, this user agent actually makes sense. If it doesn't, if it fingerprints as Windows 10, Windows 11, something weird's going on. Something's up. Oh, yeah, and it's running Java version 1.7. Oh, my God, I hope not. There are so many vulnerabilities between there and here. This is HTTP traffic. There's 3,000 connections that took place over 24 hours. Gee, that's a lot. And hey, let's do the flat line test. Yeah, there's a flat line there. So this looks like I've got a persistent connection here. I'm going to go to view 2. This is going to analyze my session size. And my smallest session size is about 888 bytes. Out of those 3,011 connections, 2,856 of them we're transferring 689 bytes. Notice what else I've got, though. I've got 108 connections where I was transferring 724. This goes all the way up to one connection that transferred 1,300 bytes. All right, so I'm not seeing a ton of data here. I'm seeing bytes, not megabytes or gigabytes. The megabytes and gigabytes worry me. The kilobytes, not so much. So this is if this turns out to be a C2 channel, I know it's been activated. I know they're doing something, but all they're doing is just poking and prodding a little bit at this point. They haven't actually exfiltrated any files. They're probably not trying to move laterally yet. That would cause more data to get transferred. So they're just kind of poking and prodding a little bit at this point. So I'm kind of feeling like this first one is probably going to end up being evil, but let's put it aside and we'll do a little bit more research a little bit further down the road. So we'll come back to that one. All right, let me go to the next one on the list. So the next one on the list, this is going to array.prod.do.dsp.mp.microsoft.com. Okay, the DO is delivery optimization. So that's used for content patches, that type of thing. Prod means production. So that is their production environment. Array 506 is the name of one of many hosts that are probably within that production environment. So this looks like it could be our Windows system calling home to check for patches or something along those lines there. Let's see, it's connecting back to this one IP address. If I look at the digital certificate, the CN on it, that matches, right? star.prod.do.dsp.mp.microsoft.com. So notice it's a wildcard digital signature. When I create my safe list, I always like to kind of take a look at the digital certificate and see who it was issued to. Because the fact that it was issued to star.prod tells me that when I create a safe list, if I decide this is okay and I create a safe list, I'm probably going to want to wildcard everything within prod as well. Invalid certificate. Yes. So this has a problem with the digital certificate. So that's something that's worth going in and taking a look at. I will say that in this particular case, it's actually okay. This was actually a problem with the way the data was collected in the version of Zeke that was running at the time it was collected. So this says yes. Normally we would flag that and say, whoa, wait a minute. It looks like a Microsoft site, but the cert's not matching. This is a problem. This is actually okay. So this one, I'd kind of be thinking, I'm probably going to want to safe list this one. Let's go look at number 3. So with number 3, this is tileservice.weather.microsoft.com. Gee, I wonder what that is. Maybe that's the Weathers app or the Weathers tile on the Windows desktop. Yeah, that's what I think is going on here. It's a GET request. It's going to a ton of different possible IP addresses. So this is one of the kind of cool things about the web beacon is that we actually tracked this through all of those different IP addresses that it was connecting to. User agent string is just Windows MS 10. That's all it's telling us. TCP 80. It is actually HTTP traffic. So this looks to me like, yeah, this one's probably okay. So this is another one that we may potentially want to go through and safe list later on. Let's look at 1, 2, 3, 4 on the list. Array 509. Is that what we saw before? No, before we saw Array 506. This is Array 509, but everything else is the same. So this may be just delivery optimization checking in off of that. Go to the next one, ctldl.windowsupdate.com. Gee, I wonder what that one's for. That sounds like it's part of Windows Update, right? User agents Windows 10, that looks okay. We had a couple other IP addresses we hit. Now we could go in and start investigating these IPs. If I wanted to go in and say, I'm pretty sure this is Windows, let me go in and investigate an IP and see for sure. I could go in and I could click on an IP address. It's going to show me the list. And then I can pick any of them and say, I want to go to Virus Total. What does Virus Total know about that IP? Oh, here's what it's been resolving to. Georgia Tech. That makes me a little bit suspicious. Georgia Tech normally isn't part of Microsoft, right? Something weird's going on there. Let me pick another one. Yeah, these are all mapping to Windows updates. That looks a little bit better. So maybe something's changed with the address space since this thing was connected. It did have one security vendor flagged it. Let's see for what. Oh, it's part of Edgecast. Okay, that explains why. Yeah, this is probably a false positive. Not a big deal. But yeah, so this is looking like one that we could probably go through and create a safe list entry for as well. We go to our last one. Oh, this is 503. So we had 503, 506, 509, all look like they're the same type of thing. And then we have, so we had 6 we were supposed to review. Numbers 2, 3, 4, 5, and 6 all look like they're probably going to be okay. Number 1, it's making me a little nervous. We're going to want to do a little bit more investigation on that one. All right, let's see if I missed anything in the lab. So like I said, I'm going to give you the lab. And then if you're looking at the lab and you're not sure what to do, you can always jump into the hints after that and use that to kind of guide you what you need to go through and do. So yeah, I talked about this. I talked about, high level of persistency. I talked about that user agent string. We talked about this. We talked about that. Yeah, I hit all of that stuff. So the first entry, yeah, there's a lot of weird stuff to it. So we already said the first one, we're going to want to go back and do a little bit more investigation on. Second entry, we said, yeah, this looks like it's okay. Third entry looks like it's okay. We had 503, 506, 509. We said those all end up the same way. Windows Update looked like it was okay. So yeah, we said the rest look like they're all right. So the first entry looks suspicious. We may want to cycle back. The rest look like they're legitimate. Let's safe list these last 5 entries. So here's what I want you to do. So we're here. Make sure you leave this first one, but go in and create safe list entries for the remaining 5 entries. I'll give you one minor hint. You only need to create 3 safe list entries to cover all of them effectively. So I'm going to give you a little bit to go through and work on this one. And any questions, just go ahead and throw it into Discord.
Quick reminder, if you're using the shared instances, thunt1 through thunt3.aihosted.com, please don't actually create the safe list entries. Just go through the process and don't choose commit. The reason is that you're sharing those instances with multiple other people. And if you safe list them, people can't see those when they go to look at those same databases. Thanks.
Yep. Oh, yeah. Thank you, Bill. I appreciate that.
No problem.
There was a question about... let's see, we're on 141. Let me write that down. Someone's saying that like their IP isn't right on their VM and they're having trouble finding it. So most likely you're running into that. This is back on slide 5. So most likely if you're running into the VM changing its IP address, it's because you're running VMware. And I mentioned that it likes to change that last byte for some reason. It will always create the VM in the 192.168.149 network, but it may be 128, it may be 129. I've seen everything. I've seen it change it anywhere from 127 to 132. Why does it do this? I don't know. I don't know VMware that well. I'm sure someone thought it was a good idea to keep effing with the IP addresses assigned to the same VM. Who knows? But this may be what you're running into. So if you need to figure out what the IP address is of your VM within the VM console, right? So we can't remote until we know what the IP address is, obviously. Launch the terminal. So that's that icon. It's the icon just below the Chrome icon on the left-hand side of the screen. Launch terminal. And once you do, type in IP, if config, pipe through grep dash capital F lowercase w space inet. And what that's going to do is that's going to list out all of your network interfaces that have an IPv4 address assigned to it. Look for the one that's on the 192.168.149 network. Whatever that IP address is, that's the IP address you need to go in and work with. So if you're on VMware, give that a shot. That should take care of things for you. So I see a question about was safe listing the source IP or destination IP? Great question. So you want to kind of think about when will this be okay? So for example, let's say it's the Microsoft delivery optimization one. You're working on that. When will that be okay? Well, if this is the only Windows system in your environment, then you could do it as the pair between the two. But typically you're going to have multiple Windows systems. And if any of them are checking in on delivery optimization, that's probably going to be okay. So what I would do is I would leave the source as anything on the internal network and focus on that destination, right? Because that's the only trusted one versus all the other stuff that might be out there on the internet right now. You were saying, hey, if my user talks to this system, that's okay. but it's all the other stuff. That's the stuff I want you to go in and pay attention to. So we're effectively telling it when to not pay attention. So I would focus in on the destination for that. So Marty McFly was asking, what do you think about safe listing star.microsoft.com? So I would look at, good question, by the way. So I would look at subdomains as a risk meter, right? Let me show you what I mean. So I would look at it as kind of like a risk meter, right? So let's say I'm going to go in and I'm going to do this based on fully qualified domain name. If I safe list this, I've trusted that one system only. My exposure to risk is pretty minimal. If I go down one layer, if I say enable wildcards and I go it to here, well, now anything under prod could potentially be trusted. Maybe it should, maybe it didn't. And the further I go to the right, the more I'm actually going in and trusting. Now, the question was, would I trust anything at Microsoft.com? A good rule of thumb for me is what's in the digital certificate. So if I go back and I look at what's the CN in the digital certificate, that is star.prod.do.dsp.mp.microsoft.com. So when I create this, if I'm deciding that delivery optimization is okay for my environment, and this I want to safe list the servers that are that serve that purpose, I'll create my safe list to match what's on that digital certificate, because all those servers doing the same function are probably using that same digital cert. Would I trust everything out of Microsoft? Personally, no. Why? What if Microsoft wants to start making money off of serving up banner ads? They've done it. Well, now you've safe listed all of that. You'll have no visibility. And that might be okay. And oh, hey, maybe malicious code comes through as part of that. I mean, you get the idea. The further to the, like I said, look at it as like a risk meter or like a nervousness meter. The more to the left I can stay, the less risky it is, the less nervous I'm going to be. The more to the right I go to, the more nervous I'm going to be, the more risk I'm exposing myself to. So for me personally, I kind of stick with what's on the digital certificate. Let's see. Oh, got to import. Cool. Missed the CLI though. Just doing the web version. The very neat tool to learn on. Cool. Cool. So yes, let's kind of talk through these. So we skipped the first one, right? We said we're going to come back and we're going to talk about that in just a little bit. There's some other things to go through first. We said the second entry is okay. Well, like I said, I'll look at who is the digital certificate being issued to, and I'll use that to kind of help guide me on what to create for a safe list entry if I decide this is okay. And since they're wildcarding that, I'm going to go in and I'm going to say I want to enable my wildcards, and I'm going to do it for anything that's part of prod within the delivery optimization side. Write in some sort of comment, hit safe list, and when I did, noticed bunch of entries disappeared, not just one. Remember, we had array 503, 506, 509. Well, that wildcard matched all three of those. So as soon as I created that one safe list entry, boom, the other two went away at the same time. That's one of the nice things about using safe lists. All right, if I go to the next one here, this is tileservices.weather.microsoft.com. This is using HTTP, so there's no digital certificate to guide me on. So if I look at that and I decide, yeah, that's okay, I'm probably not going to create a wildcard on this one, right? I'm not sure what else might actually live under weather. I'm not familiar enough with this service. So less risk, making me less nervous, stay to the left as much as possible, Think about it as like, driving on an island. You want to stay to the left. So I'm just going to say for tile service, I'm going to create a safe list entry for that. Okay, boom, that's gone. That leaves us with one. This is the control delivery. Oh, actually, let me show you this real quick. I went away. So you'll notice here, you'll see a little update that pops up and says safe listing being applied. What that's telling you is that the data you're looking at may or may not include the safe list entry yet, this database is still being processed. The way we do this is when you create a safe list, we process the database you're currently in, but then we go to the other databases and start processing all of those in the background behind it. So if I go back to a database from 2 weeks ago, let's say I open up a database from 2 weeks ago right now, this safe list is going to be part of that data set as well. So these don't just live with this one data set. These follow all the different data sets you view, which kind of makes sense, right? Because if I'm manually importing data tomorrow, I want these safe lists there when I review the data for tomorrow. I don't want to have to go back through all this stuff again. So the safe lists stay persistent. So this one, same as the last one, I'm just going to go in and say, I'm going to stay to the left because I feel more comfortable. And I'm just going to say, I don't want to trust everything in Windows Update, just this one subdomain. And I'm going to safe list that. Now we're down to the one we were worried about and the one we said we didn't have to bother to check. Everything else is gone. So imagine tomorrow or a week from now, we come in to do a hunt and everything's the same. Well, the only thing we need to pay attention to is the one entry that looks like, yeah, this is something we're probably going to have to investigate a little bit further. All right. And we're going to come back to that one. Like I said, our problem childs, we leave those for the end. So here's what I want you to do now. Go to long connections. Anything that's over 5.5 hours, I want you to go through and kind of take a look at it and decide, is this something I need to be worried about or not? Let's see. DO is delivery optimization. Correct. Correct. It is. If you live in a managed environment, do a query. Yep. Try not to panic. Yeah, really. Neat. So your safe list will prevent duplicate hunting efforts, even for new imports. Absolutely, Sappy Turtle. That's kind of so we wanted this to get easier as you go along. So that's why I was saying I'm going to hunt 3 or 4 times. I'm going to find stuff like that because not everything may pop up in one day, right? There might be some stuff that doesn't show up till tomorrow or whatever. So usually my first hunt, that's where most of this stuff is going to go away. And then my second, third, fourth, I might find a little bit more. But after that, the only thing I need to worry about is new stuff that has a persistent connection to it. This carries forward to kind of clear out the stuff that we've talked about in the past. Stay to the left for network traffic, stay to the right for real traffic. Yeah. Well, that's why I clarified if you're driving on an island, because most islands, you drive on the left. And I'm curious if anybody knows why. Why is it in some places you drive on the left, but then, in the US, we started right off driving on the right, because in Europe, they actually used to start off driving on the left if you go back 100 years ago. Why did some places start on the left, some start on the right? I'll give you a hint. It didn't have anything to do with cars. All right. So think about that. And you got 2 here to investigate. Take a look at them, come to a decision as to whether this is something you need to be worried about or not. Okay, I'm kind of feeling like I might have completely removed anybody's ability to do the lab by talking about the horse thing. Because, oh my God, we just went way too down the rabbit hole in Discord over that. So, yeah. So, why did people drive on the left initially, but it didn't happen in the US? Well, because in Europe, when you rode a horse, you stayed to the left, and you stayed to the left because by passing someone with you on the left and them you on your left-hand side of the road and them on their left-hand side of the road, you could see their weapon hand. So if they had a sword, if they had a gun, you'd be able to see it. If that hand moves and does something, you would be able to see it. It was a better position to be able to defend yourself with. So when they started driving cars, I guess in the UK, they thought, well, we might continue to shoot each other as we go by. So we will continue to stay on the left-hand side of the road because it's safer. And, in the US, we didn't grow up with that type of culture. So we just decided, screw it, we'll drive on the right. And, that we made more cars than anybody during that time. So it kind of ended up that way. Little did UK know, they're worried about shooting each other in drive-bys. Yeah, no, that was going to happen out in LA. London would never be able to hold a candle to what happens in LA with that. So that was the horse thing. But as for the lab, Your request, the thing was, hey, we got 2 connections here to go through and review. Well, these things we need to worry about. Now, the first thing I want to draw your eye to is this. Notice under protocols, port services, it doesn't list out the application being used. Normally, that would trouble me. However, here's the issue you run into with long connections. Zeke needs to see the start of the session in order to identify what protocol was being used. I mentioned with HTTP, the client sends its hello, the server sends its hello, the server sends its digital certificate, boom, everything's now encrypted. So Zeke needs to see that to know that's an SSL TLS session. Well, what if the connection started before this PCAP was created? That's what we ran into here. So that's why the application isn't being identified. So if I know my PCAP is 24 hours in length and I can see that the capture pretty much ran that entire time the PCAP was running, that kind of tells me, okay, this probably happened before the PCAP launched. So that's why I can't understand the application layer. That also explains why I don't see a fully qualified domain name, because that DNS query is going to happen first and then the connection will happen. But again, that also took place prior to 24 hours. So I'm going to drop my resolution here for a second just to kind of show you what I'm talking about here. See, once the connections are a little bit shorter and you can see everything, now we can actually see the protocol being used. Now we can actually see what was being queried when that connection took place. So when I'm analyzing long connections, if it's like 24 hours or longer and I'm not seeing app and I'm not seeing fully qualified domain name, it may just be that data was never collected as part of this data set, and that's okay. So we don't have that to work with. But I'm looking at, okay, I've got a TCP connection going to port 9200. That's kind of weird. So let's just kind of start by saying, okay, let's investigate this external IP and see what we can learn about that. So I'm going to go to abuse IP just because, hey, I haven't picked that one yet. And this one says, oh, there's 2 reports found in the data set. This resolves to demo1.aihosted.com. What is that? So I wouldn't do this from an IP address inside my environment. I would go to like a virtual desktop out of Amazon, right? Launch a virtual desktop in Amazon or within Microsoft or something like that to do it from there. But hey, let's just plug this into a browser, www. Where they were going. And let's see what this domain is. Oh, this is Active Countermeasures. Who are they? What do they do? Is this a potential business partner? Hey, purchasing group. Do we have any POs with Active Countermeasures? Have we hired them as vendor or something like that? They'd be able to tell us for sure. Yeah, and this is what I mean by like sometimes people don't know what they're talking about. Found in my Zeke logs. Really? That made it evil? Really? The fact that it was in your Zeke logs? So I guess everything at Microsoft and Amazon and NTP servers and all of them are also evil too? Really? Because you found it in your Zeke logs? DNS compromise, DNF poisoning, spoofing. Really? All of those things all at the same time? Really? DNS compromise, FTP. We don't even run FTP. Oh, you're getting FTP brute attack out of that. VPN IP, SQL injection, brute force. Hey, how many things can I click? Hacker BJ. Just that acronym tells me I can't trust this person. I'm sorry. So, you get the idea. Look at these. Just because it ended up on a report doesn't mean it's something that's actually worth paying attention to. I like to kind of look through and say, does the comment match what the category is? Does this person seem like they know what they're doing? Found in my Zeke logs, abuse DDB. What? How does that explain what you think is going on? I always kind of pay attention to stuff like that. But it's going AIH hosted. Like we said, if we just follow that from an external system, I wouldn't do it on my internal IP. Well, wait a minute, Chris, you're hitting the website. What if it's the attacker and the attacker sees you coming? Well, what they see is an IP address in Amazon connecting to port 80 or 443. Trust me, we will be one of thousands that do that today. It won't just be us. People are hitting ports 80 and 443 all over the internet all the time, all day long, 24 hours a day, 9 days a week. So we're just going to mix in with all of that. But I wouldn't do it from the local network just in case. That might be something they know to look out for because that's a network they broke into. They might miss it. They might not. Why take the chance? Again, leave no footprint if you can get away with that. So hitting a website to me is not breaking that passive active line that I talked about. So step one would be run this down. Let's imagine purchasing tells us, oh yeah, the security group, they did something with that. Oh, okay, cool. Oh, hey, my neighbor took the muffler off of their motorcycle. Yay, I'm going to get a good night's sleep. So this first one, let's say we could run that down. We decided that's a business partner. Yeah, I could go in and I create a safe list entry for that. So I could go through and say just this one IP or everything on my internal subnet going to anything in that subnet. Then no, I don't want to do that. I want to do it to the IP level, but maybe I'll just do it based on destination. So I'll say anybody is my source. Anybody on my internal network, when they're talking to that IP, that's okay. And I'll go in and I'll create a safe list entry for that. All right, now I got one left. Let's go see what we can learn about that. We'll go to Abuse IPDB again. This is run by Microsoft. IP was reported 5 times. Confidence of abuse 0. That tells you something about the reports. Hacker BJ. No, it wasn't Hacker BJ this time. It was a bunch of other people. Blocked by Soho. Oh, well, now I know not to buy this tool. All right. Because if this turns out to be Microsoft, they're breaking my connectivity. I don't want to pay money to have my network broken. Let's see, BF hack. Really? Let's do one more on this one. Let's go to where do we want to go? Yeah, let's try Alien Vault. And Alien Vault is telling us they tried some HTTP connections to that. Usually this yeah, here we go. DNS information. That's what we're looking for. Status, whitelisted. So they're saying, yeah, go ahead and report evil things. We're going to ignore you because we know this site is okay. And if I look at the history as to what's been associated with this IP, Azure.com, 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 trafficmanager.net, Windows.com, akadns.net. All of those are related to Microsoft. So this is Microsoft related traffic. Now, is it Microsoft traffic that I want to let through? That's something I need to make a decision about. I need to run down a little bit more. Why is my system connecting to this host? But we're starting to lean more towards, yeah, this one's probably going to be okay. Yeah, or first keep money works. Yeah. Cool. So one other thing I want you to take a look at. So long connections look okay. We had a beacon web that we said, this one looks like it's problematic. This looks like it's something that we might want to pay more attention to. It was an HTTP session, right? Let's go to client signature module. We haven't looked at this one yet. So the client signature module in view 1 is going to show us the HTTP host information. If we go into view 2, it's going to show us our JAR3 hashes that are associated with this host. But what we were looking at was these 3,011 connections going to this one IP address. So notice these are all 192.168.99.51, right? So it's all the same source. When it was talking to adl.windows.com, it identified itself as Wicca agent. Okay, that sounds kind of weird. No, it's actually a legitimate agent string. That one's okay. When it talked to all of these different systems, it identified itself as Windows 10. When it talked to that tile service, Windows 10. When it talked to all of these services, there we go. When it talked to these 4 different systems, it identified itself as, Microsoft Delivery Optimization running on Windows 10. When it talked to this one system, that's the only time it identified itself as being Windows 7. That's a problem. So I am a guy named Shodan. It's not a guy named Shodan. It is actually a website named Shodan. Um, so yeah. So this is super suspicious to me now. I've got a system that I can see is normally identifying itself as Windows 10, but it's also sometimes identifying itself as being Windows 7 when it talks to this one system. That's a problem. So I'm feeling pretty confident that that's a system that I need to be concerned about. Um, now that I'm pretty sure this is probably a C2 channel, the next thing I want to make sure I go do is go back to my Beacons web module, go to view 2, and look at does it if this is C2 and I'm leaning towards it probably is, has it been activated? Okay, when I look at view 2, look what we get. Here's my heartbeat. So out of those 3,011 connections, 2,856 of them are my heartbeat. Okay, that's not good. That leaves somewhere north of 160 that could be potential activation. So knowing we may have some activation here, how much data is getting moved? Well, 108 connections with 724 bytes. That's not too bad. What's my biggest? My biggest is 1,300 bytes. Okay, we're still looking at, yeah, this is somebody just poking around a little bit. This is not, they've started grabbing files off of the system. It's not they're doing, let's say, a ping sweep of the internal environment and enumerating information off of my internal host. That would generate a lot more data than this as well. So it's looking like we got a C2. It looks like they haven't quite activated this yet. This is looking like something we need to go in and pay attention to. This is something that I really want to kind of dig into a little bit further. Well, we've kind of gone as far as we can with the interface. So what we'll do when we come back is in the lab one directory, here are all of our raw Zeke logs. Can we find anything in the raw Zeke logs that'll help tip us more towards it's definitely C2, or maybe this is something we don't need to worry about? So it's the top of the hour. Let's go through and take a break. We're going to take a break for 10 minutes. At 10 minutes after the top of the hour, we'll come back in. We'll jump into this. I'll give you a little bit of time to work through it, and then we'll go through and we'll cover it together. Okay, we still have about a minute before we're going to start up, but see a couple questions in Discord, so I want to go through and kind of hit those. Let's see. Agent Zero was saying, hey, I've been in the chat the entire time. Does that count? And do I have to separately be on the Zoom call myself? So yeah, normally you have to be on the Zoom call to have the certificate automatically issued out. With that said, we do have classes where the professor signs up and there's multiple students in the class, and we want to be able to give a cert to the students if they've gone through and done this. So the fact that you're in the chat channel, Agent Zero, tells me, yeah, you're attending even if you weren't on the Zoom call. So here's what I'd like you to do. Drop a DM to Shelby. Tell her, give her, so the code word with Shelby will be horses drive on the left. And if you tell her that, that kind of lets her know you were in this session and you know what's going on. So, and you were listening in. So tell Shelby, horses drive on the left. Here's my email address. Can I get a copy of the cert? She'll take care of you. But so if you're on Zoom yourself, please don't do that to Shelby. Don't spam her. But if you're in a situation like Agent Zero is describing where, this is a community thing, there's a bunch of you in there watching it, and your account is not the one that it's signed in with, and but you want a copy of the cert, yeah, drop Shelby a DM and let her know that, and she'll take care of you. Cool. We had another question. Can you have multiple heartbeats with series of activations? That is a great question, GDAX. So typically within a specified time frame, there's only going to be one heartbeat, but you can see it change over time. I have seen situations where it's going off once every 2 hours, right? And it's a 2-hour repetitive signal that's going off. And then all of a sudden it drops to like once every 30 seconds. And then after that, it eventually extends back out to the 2 hours again. What some advanced adversaries may do is they may set up a when they go so the channel is there for them to use, but they want to have a longer timeout so it's harder to detect. Well, a 2-hour beacon means that if I type in a command, I might have to wait 2 hours before I can type in something else. That's not very effective. So what some advanced adversaries do, and this is rare, but it's possible, is that when they start typing, the beacon interval drops to something much lower, like every 10 seconds, every 30 seconds, because they're active on the keyboard. And now that they're doing stuff, that it's going to be much more responsive. But as soon as they stop, and they stop for a predetermined number of cycles, usually it's between 5 and 10, they don't type anything, it goes back to cycling every 2 hours or so. So you can actually end up. So I mentioned a bimodal check that's being done with Rita and AC Hunter. That's one of the things it's designed to identify. When you have two quote unquote heartbeats running at different time intervals, it'll pick up on those and figure out, yeah, no, this is still C2. You need to go in and pay attention to. That is a great question, though. Cool. Let's see what else we got. Do we post Q&A in this channel? Absolutely. Denecto talks. Yeah, those great set of, yeah. So send her those icons. Yeah, exactly. Send her those emojis anytime you've got a question or you want to get the cert thing done. I think you can use a subnet for a heartbeat if they're using a few CDN IPs. So if I'm creating, so so first of all, excuse me, if I'm beaconing out to a CDN, I don't want to be doing the match at an IP address level. So let me jump into this real quick. So the beacon screen does its analysis based on IP to IP. But if I try to do this and the target IP is a CDN, legitimate traffic's going to be mixed in there. We talked about that. And some of these beacon signals will be going to a different IP. So I'm not going to get a very accurate read out of this. That's what the Beacon Web module is for, because the Beacon Web module goes through and it uses that host parameter or SNI parameter so that if a CDN is there, it's mapping it through any CDN server it happens to touch. So if I want to go in and create a safe list for that, I'm not safe listing that CDN. I'm safe listing that fully qualified domain name if it happens to be using that CDN, and that's it. Hopefully that makes sense for you. Are you a Van Halen fan, Chris? Yeah. Well, so if I had to like pick one band that like I was probably wicked into the most, it was definitely the Grateful Dead. I never quite made it to seeing 100 Grateful Dead concerts. I made it to around 90, and that was it before it just got too commercialized and I stopped going. But that was the big one at the time. What am I into now? Probably more ZZ Ward. I kind of like the, kind of bluesy side of that. But yeah. And yeah, no, my hair was never quite that long. Almost, but not quite. All right. So I'm going to give you a couple more minutes and then we'll cover this. Hopefully you've had a chance to kind of poke in this a little bit. But we talked about this IP address, right? Where the HTTP server was identified by an IP. So this IP address here, 104.248.234.238. We said that looks really suspicious. Is there anything we can find going back to the raw Zeke logs that might help us figure out, is this something we need to worry about or not? Let me give you a little bit of extra time to cover this one, and then we'll go through and we'll chat about it. Okay, I've got to get away from Discord or I'm just going to keep typing silly things. So one of the things that kind of grabbed me was that the host parameter was an IP address. So one of the things that kind of grabs me right off the bat is, were there any DNS queries associated with that IP address? In other words, if the host parameter is an IP address, and there was no DNS queries taking place as well, that's a pretty good indication that we've definitely got something funky going on here. So what I'm going to do is one of the logs that Zeke creates is dns.log. This has all of the DNS queries that took place on the network. So I'm going to go through and grep that log and see, okay, were there any queries or answers that have this IP address associated with it? Because anytime somebody goes to a website, this is going to TCP/80, I would expect them to be going to a fully qualified domain name, not directly to the IP. And you can see I don't have a match. Now let's just take a quick look at that file just so you can see what it looks like. So you can see this is, who's sending the query. Well, and I get a lot of IPv6 stuff in here. That makes it harder to read. Let's come down here. That might make it a little bit easier. Here's my source IP, my destination IP address. Notice multicast stuff and broadcast stuff goes in here as well. So this is UDP 137. So this is a Microsoft system broadcasting locally. Hey, this is my name. I am desktop BSOUDS11, just in case anybody cares. But let's kind of talk about this one right here. So this is a real one. So someone looked up arc.msn.com. So that was the query. And then the answer that came back, let's see, it was a CNAME. Oh, it was an A record query. Yeah, here we go. So here's the answer that came back. So here's the IP address that got associated with that. So you're normally in this log file, I'm going to find, hey, here's the name somebody was trying to get to. Here's the IP address that came back for that. But when I went in and went looking for that IP address, I didn't get a match on anything. That's bad. That's something that makes me really sad, and it's something I'm going to be worried about. Now, let's go take a look at what we have in the http.log file. All right. So I'm just going to go in and take a look at that real quick. And here's that 104.248.234.238 address. So all of these entries is that one right off the top. So this is a GET request. Here's the host parameter being an IP address like we talked about. Here's the URI they were actually requesting. Oh, that doesn't look right, does it? This looks like a long string of alphabetic characters that goes on and on and on. Look at this long string. All right, and here's the end of the URI request here. That looks weird. I mean, it's certainly possible, but it looks weird. Something doesn't look right. Let's see, they were using HTTP version 8.1.1. Here's my user agent string here, or at least the beginning of it. Here's the full user agent string that was taking place. So the host parameter looks wrong. This URI looks weird. That is making me really nervous. So what I'm curious about is it kind of, if I just look at the screen, it kind of looks like it's the same URI over and over again, right? But it'd be nice to test that theory. So how could I test that theory? Well, I could say cat http.log. Now, if I just print that to the screen, that's just going to dump all the output to me. That's not going to be very helpful. So I want to go through and I want to limit what actually gets printed out. So I'm going to say Zeke cut. I want to look at id.resp_h. I want to pull out the destination IP address. And then I want to go through and I want to pull out the URI. Then I'm going to go through and say, okay, take that output. Now, if I just print that to the screen, here's what it looks like. Okay, so I'm getting that IP, I'm getting that URI. Now what I want to do is I want to say, I want to make sure I'm only looking at URIs that are going to this website. So I'm going to say I want to grep for the IP address that was used on that website, 104.248.234.238. And now it should only show me results from that. And then what I'm going to say is I'm going to sort it. Unique-C. What's that do for me? Well, sort is going to go through and say, okay, anytime the source IP address and the URI matches, put those one line after another. Because we don't know for sure if this is always the same or if this line is changing slightly. This O might change to a 0 someplace, and visually I may never notice that. So sort is going to go through and put one line after the other when they match. Unique-C is going to go through, excuse me, let's just use unique for now. So I'm going to say unique, and you get some white space so it's easier to read. Unique is going to go through and print out one instance of each, just like we see here. But if I say unique -C, that's actually going to count up how many entries I have. So I saw in AC Hunter there was 3,011 connections total. This is telling me all 3,011 connections have this really long URI to it. Now I saw a question about, hey, does AC Hunter help you kind of run this down? Well, a little bit. It doesn't help you recover. It's not going to clean your system for you, but it will kind of give you, point you in the right direction to kind of figure out what's going on. One of the things we may want to identify is, what malware is this, right? That kind of comes down to knowing what to look for. We could look for this very long string URI, right? That looks very unique. We want to pull something unique versus legitimate traffic. That's certainly long and looks unique. So that's something we could search for. But it's long, it's coded. My guess is that might be unique for our system. So I'd actually just go back and search for this. I'll bet searching on that is going to result in helping us run down what malware might be on this system. Once we know what malware is on this system, now we know what tools can remove it and what needs to be done to actually go through and clean that up. All right, let's see if I missed anything. So creating safe lists. We haven't moved slides in a while. So we did that. Yeah, we created all the safe list entries. We did that way before the break. I talked about, stay to the left to stay safe. Think about you're riding a horse with a gun. Stay to the left to say, reduces your risk type of thing. Creating that array entry, as a wild card, removed all three at the same time. And we had 3 we had to create for safe lists. The edge.skype that was left over from earlier. Let's see, long connections. We went in and we looked at that. I mentioned that, that first one, AH hosted. So we said we could go outside of our environment, right? Hey, if I carry a cell phone, launch the browser on my cell phone, shut off wireless. Now I'm on my carrier. Verizon, AT&T, whoever it happens to be, connect from there. There's a nice, easy way to go through and do it where you don't even have to spin up a virtual desktop someplace. But check it out. Does purchasing know about that organization? Visit it from a non-related connection type of thing. Okay. The second one, we talked about that. It looks like it's Microsoft related. We create a safe list entry for that. So that left us with this one suspect one. So just to kind of sanity check where we're at, all the beacons, all the long connections we've looked at, all of them were okay. It was just this one that was bad. So we deep dived on this. So we went and we talked about, hey, the user agent string, Windows 7, only when it's talking to this IP, that's bad. I talked about, if this is C2, it looks like we got some minor activation taking place here, but they haven't actually stolen any data. Talked about this. We talked about how there was no DNS queries done that resulted in this IP. That's a big, huge red flag. People use fully qualified domain names for connecting. Let's see, should be a fully qualified domain name. We talked about that. Usually Windows 10, but it's sometimes Windows 7. We talked about that. The user agent string, we looked at the same thing. We just went in and we did it through AC Hunter instead of doing it on the command line. And the URI analysis, we're connecting to the same long, convoluted URI over and over again. And I said, hey, if we Google the URI, that may not help, but this directory name might be short enough, but still unique enough that Google might be able to kind of help us out. Googling it returns, this is Fiesta. So this is actually known malware. Now, bam, we need to push that big red incident response button. We need to get a bunch of people together. So the next thing I would do, right? So after I've done this, my next step is go here, go to, I got to go here, go to deep dive and say, is this the only IP address talking to this? Because that's going to identify my scope. Now we need to move in incident response mode. Hey, this system is infected with Fiesta. This is the command and control server. This is the only system identified talking to that command and control server. as an incident response team, what do we want to do for next steps? The next step for me would be isolate the box. Step 2 might be, okay, let's see if we can figure out how much data left the system. Step 3 might be, hey, can we nuke the system? Because we don't want to just clean it up and hope that they didn't put another backdoor on it or do something weird. This should never go back. This system should never go back to the user. The system should be, put aside for full analysis type of thing. All right. So yeah, one thing kind of worth noting was that there was 14,000 connections in this data. Only one was evil. We talked a lot. Without all that talking, we could actually have found this pretty quickly, right? Let's do our next lab. So this time, I'm going to let you go through the beacons, the long connections on your own. And I'm going to let you very quickly identify what do you think is here that you need to worry about. If there's things you look at and you think you're okay and you want to safe list it, safe list them, get them out of the way. Anything you think you need to worry about, yeah, that's what you want to focus in on. But I want you to follow along with me here to make sure we all do this right, to go through and import this next set of data. So I'm in the lab 1 directory. I want to do lab 2 now. So I'm going to say cd space .. lab2, lab 2. So that's telling the operating system I want to navigate up 1 directory and then back down into the lab 2 directory. When I take a look, I've got some files in here, and I'm going to say Rita import star.log, exactly what we typed last time. Only this time I'm going to name it lab 2. So I need you to do this as well. Go to the lab 2 directory, Rita space import space star.log space lab 2. Hit enter on that. It's hitting you up for the password. Password is hunting, all lowercase characters, and then just let it run through and do its thing. Now, I want you to notice something. I want you to notice that when it was importing the data, no beacon data to analyze, no proxy data, no TLS or HTTP beacon, but it found some DNS stuff. That summary might be really helpful in figuring out what we might run into as part of this next lab. So here's what I want you to do. So once you've done that, go to the dashboard, go to the gear icon up here. You'll now have a lab 2 directory, or excuse me, a lab 2 data set. Select that, hit confirm. Oh, wait, Chris, it says no results found. Something's wrong. What's this mean? We talked about that earlier. I'll give you a little bit to work through this one, and then we'll go through and we'll talk about it. Any questions you have, go ahead and just throw it in the Discord channel. Hey, so somebody asked, is there a way to get that URI information out of AC Hunter without having to drop to the command line? In this version, no, there's not. You got to go to the command line. In this version, that will probably be changing in the near future. That's all I'm going to say on that. We have a big rewrite coming. Hey, so I know I'm going to butcher your screen name, and I apologize. Nifal T. Sorry. The person having problems doing an import. Here's what I want you to do. So this is only if you're having problems doing the import. Do a Rita space list. And what that's going to do is that's going to show you all the data sets it has. Look to see if you have a lab 2 data set. My guess is you do. And it sounds like you only did a partial import of that. So how can I delete the data set and start over? That's exactly what I'm walking you through. So please, please, everybody, do not do this. This is just if you had problems with the import. You can do a Rita space delete space lab 2. Hit enter. When it asks you, whoa, you're going to nuke this data set. You sure you want to do this? Hit Y for yes. It will nuke that database. And then you can hit up arrow to rerun your reader import command, and you won't get that error anymore. What it's telling you is The rolling data set is a special data sets that it's designed to have data constantly appended to the end of it. And the lab 2 data set, we didn't set it up that way. We just said, yeah, we're going to do one import and be done with it type of thing. So it's flagging that, but you're not actually trying to do that. You just had a failed import, then a partial data set created. So nuke it using the delete command and then start over. You'll be in good shape. All right. I'm going to give folks another minute and then we'll talk about this one. Again, that's interesting. If you think you figured it out and you want to dig a little deeper into what's going on, you could go back to the command line and take a look at the Zeke logs that are here. Yeah, so Bill mentioned the lab systems already have that created. So yeah, we've got a shared instance running that people can jump into if they need to. And the challenge there, of course, is that people are all sharing the same thing. We're actually looking at moving towards cloud labs. We didn't have time to actually get this up and running properly. But one of the nice things about this is you log in and you have a copy of, hey, here are the VMs that are available to you on your account. So we could set people up for this and just, make that available. And then once you click start, you give it a little bit of time to go through and start up, and it'll run for 4 hours. And then after that, it will just die. But when you click over to running copy, oh yeah, I haven't done anything in a while. When you click over to running copy, it will show you any VMs that have actually been loaded up. Yeah, see, this is one of the reasons why we didn't go live with it yet. Sometimes it runs a little slow. We need to see if we can't get that straightened out before we'd actually make this part of the class. Oh, it already nuked them. That's why it's not doing anything. All right, so I need to start one up and then it'll take a little bit to run. But in any case, I'll come back to this, but once it gets up and running, you actually have a copy of the VM running that you can interact with through a website, and it's only your copy, so you don't have to worry about conflicting with other users. So the next time we're gonna run this class again is in August. We're hoping to have this up and going by then. But let's go back to the lab. Actually, I'll just do it right in AC Hunter. So yeah, no results found. So initially it can look like, oh yeah, no, everything's great. No results found. Well, no. DNS is different. Why is DNS different? DNS is different because of the way the protocol works, right? My users ask the local DNS server questions, and the local DNS server then goes out to the internet for them. Well, if I'm monitoring on the perimeter, the IP address I'm seeing doing suspect activity may not actually be the true source. It may just be my internal resolvers. Further, the internal DNS server may ask that question. Let's say I've got 3 internal resolvers. It might ask this question of one and then another and then another. We need to combine those together to be able to identify a proper beacon signal. So the fact that this says potential C2 over DNS tells you jump into the DNS module and go take a look at that. So we had 2,074 unique resources queried within honestimnotevil.com. Oh, well, the name says they're not evil, so I'm sure they're fully trustworthy, so we don't need to worry about this, right? I'm sure it's perfectly safe. Nothing to be concerned about here. So yeah, that's a lot. We said for a domain I don't recognize, 10, maybe 20 max. It should be something south of that. This is over 2,000. That's a problem. All right, if I look at the utilization, my internal DNS server is doing a lot of queries, but nobody's connecting to this net, to a resource in that domain. Remember we looked at like Akamai and the legitimate traffic, and we said, hey, yeah, users are going in and actually, accessing those resources. That's what we expect to see. So we're querying a lot of resource records. No one's accessing those resources. That's looking like C2 over DNS to me. All right. So what if I want to dig into this a little bit deeper? Well, this is only looking for, 100 resource records or more. If I drop this down to 0, I can actually see the individual queries. So look at what these queries are. It's things like 5DA0B7F9, blah, 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 .honestimnotevil.com. Oh, yeah, that's shorthand file server, right? No, we don't name our systems this way. This is not the type of name convention anybody would use. One thing that's kind of interesting is if you look at it, those look like hex characters, right? It's not ASCII, it's hex. 0 through 9, A through F are the only valid characters you ever see show up. Somebody has encoded this. So somebody said, hey, if I put the ASCII characters in the name, someone might notice that and get suspicious. But if I recode it into hex, people will look at that and say, well, hex is not my native language, so I'm not sure what that's saying right off the top of my head. So I guess it's safe and it's okay, and I don't need to worry about it. Yeah, you do. Yeah, you do. Something else is going on here. Could we extract this hex and convert it back to ASCII? Oh, yes, we could. But that's part of the advanced class that we go through and do that. So I'm not going to go down that far down the rabbit hole from here. But yeah, we could cut out what that hex is and go in and take a look at it. I'll give you a hint. It is definitely a command and control channel. And they know what processes are running on that system. They know what files are in the Windows directory. There's a lot of things our attacker has learned about that local system. All right. So this one, I wanted to kind of throw a curve at you, right? Because we had stepped through all the things and then, okay, here you go on your own, and bang, it's completely different. Because that's kind of how life works, right? And life kind of works that way. You learn something in class and say, okay, I'm going to get back to work and I'm going to apply it. And woo, here comes something out of right field. I kind of wanted to do that to you on purpose, just to kind of get you used to, hey, just take your time, look at what's going on. You can figure this out. So even though it popped up and said no results, if you notice that sent you right down the right path. And you could figure out that, we got C2 over DNS to worry about. Would CyberChef be able to decode it? Yes, it could. You just need to get the hex out. So if it was me, I would use something like Zeke cut to cut out that query field, and then use something like the cut command to go through and just pull that out. If it was me. All right, we got one more lab to do before we finish up this class. Let's get this done pretty quickly. So I'm going to say cd //lab3. So now we're in the lab3 directory. We get a couple files in here. And now we want to import that data. So I'm going to say Rita space import space, you guessed it, star.log space. What should we name it? Bob, Nancy. No, we'll just name it lab3. So Rita space import space star.log space lab3. This will import all of our Zeke logs in this local directory, and it'll put it into a data set named lab3. Now, we've been using Zeke consistently as our data collection engine. Will this work with anything else? Yeah, actually it will. There's a couple other formats we support. Zeke is the best, though. So, for example, like you could use NetFlow. The problem with NetFlow is you get nothing at the application layer. So where we can go through with Zeke and tell you this was the query somebody performed that caused them to go to this IP address. If you're trying to pull in NetFlow data, that data is not there. We're not going to be able to tell you that. So yes, you can use NetFlow. You're going to find it a lot more frustrating. So now that I imported Lab3, I just go in and select it, confirm to load the data set. And this time I want you to go through Beacon Web, go through DNS, go through long connections, all those modules we've talked about so far already. And I want you to look at, is there anything in here that's interesting that may be worth paying further attention to? Anything you see that you think is okay and you want to safe list, just go ahead and safe list it. I'm going to give you a little time to work through this one. As Bill is saying, if you're on the shared systems, Rita, the Lab3 has already been imported for you. So all you got to do is just go to the little gear icon, go to the data sets, go to Lab3 and select it, and then just start doing your hunt. You didn't have to do the import step that I was doing with the folks that were running a local VM. Hey, so quick question. Somebody was asking about weird.log. So one of the things you'll notice is that most of the time, let's see, do we have one here? Probably not, because I'm calling it out. Yeah, no, of course there isn't one here, but there was in lab 2. In the lab 2 directory, we didn't have a lot of logs, but one of the ones we did have was weird.log. What is that? Weird.log is Zeke's dumping ground. When it sees something and it doesn't know what to make of it, it throws it into weird.log. So in this case here, I've got a 172.31, so I've got a private address, talking to a .2 address. It's coming from an upper port number, going to port 453. DNS unmatched reply, DNS unmatched message. What does that mean? That means that the queries were probably going by so far that, so each query has an ID number associated with it. And that way, when you get an answer, that ID number comes back in the answer. And that way, you know, if a DNS server has, let's say, 20 queries out at the same time, as the answers start coming back in, it knows which answers go to what questions. This looks like it broke down, or it may have just timed out, which is my guess. My guess is what happened here is a DNS query went out with an ID number on it. It didn't get an answer back far enough. Zeke decided, oh, there's no answer coming back. We sent a message, but we didn't get a reply. Let me make an entry for that. And then it forgot about that DNS session. And then the reply eventually came back in and it said, oh, hey, here's a reply, but I don't see an answer because it forgot about it because it timed it out already. So that's my guess is what was probably taking place here. But weird.log is just Zeke's dumping ground for things it doesn't know what to do with. All right, I'm going to give you a little bit more time to work through this one. I see people are already posting answers. That's awesome. Hey, so Agent Zero had a question. I don't see where we could escalate the IP or ticket for further investigation. So you can't do this with the Community Edition, but with the Enterprise Edition, one of the things you have control of is the ability to go in and customize these drop-down menus. So for example, let's say I use Carbon Black. I could add Carbon Black to this menu and we'll connect to it, pass it this IP address. So you could go check Carbon Black to see what Carbon Black knows about this IP. I could go in and I could add in my SIM. And I could set this up so that, if I want to do some additional research on this source, again, it connects to my SIM, sorts on this IP address. I can go in and I can go view those logs. So you can, with the enterprise version, you can modify these menus to add in different tools if you want to. So if you wanted to create a link to your ticketing system, so you could go in and you could make a copy of this record and enter that in a ticket in order to be able to escalate it, or maybe that's how you send things into coincidence response mode or whatever the case may be. Those menus are probably your best option for that type of thing. Good question. In a nutshell, could you explain the significance of looking through DNS logs with a suspect IP? I'm not understanding that part. Okay, that goes back to the first one. So let me just hit that really quick because we're running up on the end of the day here. But what I was talking about there was this was a connection to a web server. When people go to web servers, they go by the name, right? They go by, this is going to simplecloudlab.com, right? Or activecountermeasure.com. You type a name in here. Well, when you type that name in, what you don't see in the background is your system says, I have no idea how to get there. So I'm going to use DNS to figure out what the IP address is for that system. And I'm going to connect to the IP address as opposed to trying to do anything with that name. So there'll be a DNS query that takes this name and maps it to some IP address. So what I was talking about here was that there was no DNS query done that returned this IP. So nobody typed in a fully qualified domain name. That's suspicious. Think about yourself. How often do you connect to things based on IP address? Not that often, right? Maybe sometimes, but not that often. Okay, spread that out within your org. How often are your HR people doing that? How often are your marketing people doing that? Oh, never, right? They're always using fully qualified domain names. So the fact that somebody's connecting to something that doesn't have a name associated and they didn't use the name to get to it, it's just a little weird to me. That's not enough for me to say, whoa, hey, we have a problem. Go in incident response now. No. What I'm saying is on the I'm suspicious scale, that moves me a couple of notches more suspicious. because that's not normally how things work. Think of these things as like a story, right? What's the story of me browsing the web? I type a name into my browser. My system resolves it to an IP. My system connects to the IP. That's the story of how I connect to systems. What's this telling us? Oh, well, part of the story is missing. We just directly connected to the IP. It's kind of weird. That's kind of weird. Okay, let's go back to this lab 3 data set. So if I look at the scores, I've got some beacon stuff here that looks like I need to pay attention to. I got some web stuff, some IP stuff. Let's just jump right in here. So my highest score. It's my next one after this. Data.microsoft, self.events.data.microsoft.com. So that one's probably going to be okay. arc.msn.com. I think that's ads or something, if I remember correctly. So that's one that, is it evil? Is it good? It kind of depends on how you feel about ads showing up on your business systems. This might not be something I safe list so much as I create a firewall rule to block it, to stop people from going in and, having banner ads show up on their system. Fun little trick. We were talking about DNS. What I would do is I would go to my DNS server and I would say, hey, we're now authoritative for MSN.com. And if anybody tries to connect to arc.msn.com, send it to 127.001. What that does is anytime something tries to trigger a banner ad and it tries to get to arc.msn.com, it points it back at the local system. And of course, the local system doesn't have that resource. So it immediately says, nope, can't find that. Oh, well, I'm going to go on and keep doing whatever it was I was doing. So it's a quick, dirty way to black hole things, is to just go through and use your DNS server. But this first one, that's the one we're kind of interested in. So the user was trying to get to, so this is the host parameter, newbie2.skypetm.com.ty. Huh? That doesn't sound quite right, does it? Maybe skype.com.ty. I could see that, but skypetm.com.ty. Oh, that sounds like somebody's playing around with the DNS name, doesn't it? Now, that's the host parameter. Notice it's an IP address for the server. It connected up to the IP address. They didn't do that fully qualified domain name. We can go back to the DNS logs and check that, but that makes me a little suspicious. Look at this. Microsoft Internet Explorer. Oh, come on. Come on, bad guys. You're not even trying. You're totally just calling it in. That is not a valid user agent string. That is some hacker sitting in the basement saying, oh, I need a user agent string. What should I use? Well, people know about Microsoft Internet Explorer. I'll type in Microsoft Internet Explorer. No, that's not how it identifies itself. If you actually bothered to look, you'd see it identifies itself as IE space and a version number. But that's not what they did here. Microsoft Internet Explorer. Yeah, no, that totally tells me this is fraudulent. Something weird's going on here. We got 3,000 connections in the course of the day. Look at this. We got a little bell curve. Cobalt Strike, right? You should be hearing that in the back of your head when you see a little bell curve here. So yeah, this is looking like a possible C2 channel. Has it been activated? Well, we've got our heartbeat down here at about 628 bytes, and I do have a couple of connections showing up later on. I have 93 of them that are 828 bytes in size. Okay, that's not much. I think we're still looking at, this is an actual activation. This is maybe somebody just checking connectivity type of thing. They're not moving a lot of data yet, same as we saw with the other ones. So that kind of grabs my attention a little bit. So let's kind of go down this rabbit hole a bit. So the first thing we were looking at is the fact that we're seeing an IP address. We're not seeing a fully qualified domain name. So that makes me a little bit nervous. So I'm going to go in and I'm going to say, I want to grep that IP address. I'm going to say, what is that? 159.65. And I'm just going to look for that. That should be plenty to keep it unique. In the DNS.log file, there's nothing. So nobody ever queried that. Let's try that name, right? Let's grep Skype TM out of DNS.log file to see anybody did any lookups for that. No, they didn't. So no one ever tried to get to skypetm.com.ty. No one ever, did a query that resulted in this IP address coming back. That's suspicious. That's hugely suspicious. Something's going on here. All right. Let's see. What else can we look at? Let's go in and take a look at what else might be fun. Oh, yeah. Let's take a look at this is HTTP traffic, right? Yeah, let's go in and take a look at the HTTP.log file. So I'm going to say grep space Skype TM. I know it's going to show up in the HTTP.log file because that is part of the host parameter. And I'm just going to pipe that through less. Let's see what we got. Okay, so this is my internal system connecting to that IP address out on the internet. The host parameter is newbie2. Come on, really? Come on, bad guys, get a little bit more creative. You're making this too easy for us, right? newbie2.skypetm.com.ty. Okay, that makes me suspicious. They're connecting to this really long, weird looking URI again. It's different from the other one, but it's the same type of thing. It's a very long encoded string. That makes me super suspicious about what's going on here. User agent string, Microsoft Internet Explorer. Oh, come on. You're not even trying. 200, okay. So that long string was sent to that remote server, and the server said, I'm okay with this. I consider that to be a valid link. And there's nothing else interesting in here. If we were to go through, do a sort unique sort, which I'm not going to bother because we're at the top of the hour, this is the only URI that ever gets hit. So now we're down to what do we search to see if we can't find this on Google? Well, before we use the directory, right? Well, that's a hex string, FC001. I'm going to see a lot of stuff I don't care about with that. If it was me, I'm going to start Googling this to see if I can't figure out what's going on. And what I think you're going to come back with, if memory serves, is this is actually Zeus crimeware that's using this link. If I remember correctly, I might not be. So let's take a look at slides and see if I forgot anything. Wow, so this is still in the lab. Wow, lab 2. Yeah, we already worked way past that. So yeah, we talked about this looks scammy. Your user agent string is wrong. The time tells us, yeah, this definitely looks like C2. It looks like it's probably Cobalt Strike. Yeah, this gets flagged. If we go in and we do a lookup on that domain in one of our tools, it pops back up and says, oh, yeah, no, you need to be worried about that. That's something that's bad. So we didn't do that, but we could have. Do an HTTP identifier on this. Oh, this is some of the other entries. So we had some Microsoft traffic in there we could safe list. Basically, everything else that was left, this is all stuff we could go through and safe list. What else? So what if you want to keep practicing, right? What if you're looking at this stuff and you're saying, hey, this was fun. I want to keep doing this. If you go to our blog and do a search on malware of the day, we have malware of the day posts that include a PCAP. Now, here's what I want you to do. Don't read the blog. When you click in on a malware of the day blog, close your eyes and page down to the bottom. Don't read it. When you get to the bottom, back up just a little bit. And what's shared at the end is a PCAP that includes a particular strand of malware. There's usually 2 of them. One of them is an hour-long file. Another one's a 24-hour-long file. Grab the 24-hour one. Now go in, do an analysis to identify, does your process help you find out everything about the C2 channel that's in there? Once you think you got all the answers, now go read the blog. If you miss something, what do you need to tweak in your processes? Maybe you forgot to check the user agent string. Maybe you forgot to look and say, hey, it's a JPEG file, but the MIME type being shared by the server was a text, was identifying it as a text file. That's a mismatch. An image I would expect to have a MIME type of image/JPEG. But if it's labeled as text, somebody's passing text through it and they just don't want you to know they're doing that. Maybe I didn't have that as part of my regular hunt checks. Maybe that's something I need to add in. So that's one way to go through and kind of practice this stuff. If you're interested in a demo, meaning, hey, I kind of like what I'm seeing, I want to take a look at the Enterprise Edition, type demo in the Zoom chat channel, please. Not in well, you could do it in Discord, but we might miss it in Discord because there's a lot of other stuff in Discord. But if you type it into the Zoom chat channel, we will definitely notice that. We will set something up on you. Price increase, we went up on the price last week, but I will honor the old pricing for, let's say, another 2 weeks. So if you get in on a demo over the next 2 weeks, we'll give you a quote based on the old pricing. Just because, hey, you showed up and spent the day for you, I want to say thank you for that. Closing thoughts. Yeah, we've talked about this. Remember your order. Check for persistency. Check for business need. Investigate that external IP. Investigate the internal IP. Once you've done that, you should be able to decide, is this something I can safe list so it doesn't show up in future hunts? Or is this something we need to go into instant response mode on? I got some classes I'm teaching coming up. If you went through this and you kind of felt like this was a little bit above what I'm capable of right now, check out the Intro to Packet Decoding class. That's a pay what you can class. So you can get in for like $20, I think it is like the minimum on that one. So you can go check that one out. If you liked this and you want to do more like it, I'm doing an advanced class on threat hunting out in August. The next time we're running this class, so if you like this and you want to come back or you want to tell a friend or whatever, August 12th, which will be a Saturday, is going to be the next time we're running this class. We're going to take a little time off just because it's summer and people are traveling and stuff like that. But we're doing the next one on a Saturday. We like to switch between Tuesday, Saturday, because not everybody has bosses that will let them attend training during a work day. Some of them are a-holes. So we try to circumvent that and say, okay, well, fine, we'll do free training on a Saturday. Now it is totally up to your choice, so long as they don't force you to work Saturdays too, as to whether you want to go through the training again. And I also do a class on security leadership, if that's of any interest to folks. That's probably one of the classes I have the most fun with. I actually just taught that this week. It's last week. It's my most cerebral class. I talk about how to solve phishing with brain chemistry, which is kind of fun. So I want to say thanks to everybody. Are these dates on the website? Probably not. But hey, you've got them in a slide, so you're good there. Thanks for attending. It's a free class, but it's not, because you just took 6+ hours out of your life and chose to share that with us. And that really does mean an awful lot to us. Too many people look at it as, oh, well, it's free. We're giving you this to free. No, it's not free. You're giving us your time back in return. And that's something that really means a lot to us. So thank you for that. Let's see what else we got. And that's all I got. So Bill, Keith, Shelby, whoever else might be on the line, if anybody else has got anything else they want to chime in with, I think we are done.
Quick reminder, we've got the certificate will be coming out automatically. You don't have to do anything else to the email address under which you registered for the class. That should be out in probably a few days. So don't check back until at least Thursday before asking where your certificate is.
It will definitely not be anything less than 24 hours.
There you go. Perfect.
Because
go ahead.
And not to sound like an a-hole, but we always have people, we say that, wait at least 24 hours, preferably 2 days, and then contact us if you didn't get it after you check your spam folder. But we always get people within an hour. Hey, where's my cert? I have not gotten my cert yet. Yeah, we told you that. So
there's a reason for that.
Yeah, exactly.
The class recording needs to be edited, and so it's going to be a few weeks before it's ready. It'll be back up on the same page where you first found the class, activecountermeasures.com/hunt-training. And again, that'll be a minimum of 2 weeks. So, but you can always look at the previous class recording, which will be up until then. Thank you again for all the questions.
And of course, Sultan is just as bad as you and I, Bill. He's already posted in, hey, so where's my cert? I know this isn't even done yet, but damn it, where's my cert?
For the right amount of Bitcoin, Sultan, I will hand draw you a certificate. You could have it in 4 minutes.
Exactly.
Note that phrase, the right amount of Bitcoin. Okay.
Yes. And Jay Brown is hit in with, hold your horses, man. Horses. We talked about those earlier. RRR. Subtle
Hey.
geek humor. RRR.
Thank you, everybody. We really appreciate the questions and the interest.
Oh, wait. One last thing before we go, or Keith will never forgive me.
Uh-oh.
Tiny hand goodbye.
Oh, hey, little
It's
hand.
a tiny hand, little hand goodbye. There you go, Keith.
Every once in a while, everyone needs a little hand.
Needs a tiny hand. Exactly. Exactly. All right, everybody. Enjoy the rest of your day. Thank you again for spending time with us. We appreciate it.
Awesome. Thanks,
We're
Chris.
done.
Thanks, everybody.
Ciao, everybody.
Bye.